as we begin to the inaugural session. To invoke the blessings of Almighty and mark the auspicious beginning of this seminar, may I request our dignitaries to kindly come forward for the ceremonial lighting of the lamp. May I request Shri Anurag Sinha, Executive Director, so we will first offer the respect to the statue and then we move towards the inaugural session of lighting of the lamp. So may I request Shri Anurag Sinha, Executive Director EIL, Shri Manish Bhateeja, Shri Bachubhai, Chairman of Akshar Developers, our Chairman of Navi Mumbai Centre, Mr. SP Singh, Dr. Deshmukh, Dr. Commander Bhandarkar Sir, Dr. Navnath Gadge Sir, Engineer VC Kamble, Dr. Rajay, and our respected dignitaries. Somebody from the organizing committee, can somebody come forward, because then after the inaugural ceremony we'll request them to be on the dais. No? Sir, before, may I request you all to please proceed for lighting of the lamp. Shri Anurag Sinha Sir, Mr. Manish Bhateeja, Mr. Bachubhai, our Chairman SP Singh, Dr. Deshmukh, Dr. Commander Bhandarkar, and all our other dignitaries. May may I request everyone to kindly rise for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Jai. Thank you. Please be seated. May I request our dignitaries, Dr. Commander Bhandarkar sir, to please come on the dais and please take your seats. And Mr. V.C. Kamble sir. Bhandarkar sir also. Bhandarkar sir also, I request you to please come on the stage. Our organizing secretary, architect Suresh Babu sir. And our engineering, Navrat Gadge sir. Azun seat hai. Last moment. So, I now invite our chairman of IIN Navi Mumbai Centre to deliver the welcome address and speak briefly about the Institution of Engineers. SP Singh sir, kindly come on the dais.
Good morning and very warm welcome to all of you. Very good morning. Thanks, sir. Sir, today we are gathered here for one of the session where we are going to enlighten by our dignitaries here. It's my privilege to welcome today's chief guest. Due to emergency, both has went for the meeting. They could not join. Sri Vijay Singhal sir and the Kailash Shinde sir, just they went for some urgent meeting and they have last moment they have dropped the meeting, but their support is always there. I welcome them, sir. Our special guest, and now today we met the chief guest to our Sri Anurag Sinha sir from EIL. He is the executive director of EIL and he has came from the EIL to enlighten our this Navi Mumbai gatherings. So I welcome Anurag sir for today's giving your presence here. And another dignitary and tall man of the Navi Mumbai, Sri Bachchu Bhai, he is here and whose contribution in this high rise is marvelous. I welcome you, sir, for today's session. Another developer from the Akshar developer is another person who is driving Navi Mumbai to the great height. He could not reach here, but he is on the way. I welcome to Manish Bhateeja, sir. He is shortly joining us, and he is leading the Paradise Group. I welcome to all the esteemed speakers. I welcome to the past chairman of the Navi Mumbai Local Centre, and presently he is leading the Maharashtra State Centre as a chairman of the Maharashtra State Centre Institution of Engineers, and he is also the driver behind this metro of the Navi Mumbai, who has made a lot of contribution to the metro division. I welcome you, V.C. Kamble sir, for today's sessions. That here we have our one of the dignitaries who has on the council meeting of the Mechanical Engineering Division Board, and who is immediate past chairman of the IEI Navi Mumbai Local Centre, who is driving different activities into this industry. He is Dean of the FCRIT, and he is present among us. I welcome to Dr. Deshmukh sir. From the Engineering Architect Division Board, Institution of Engineers, the Architecture Division Board, and he is driving Sri Om Darak sir. I welcome you sir for today's your presence. Who is guiding to the entire Maharashtra local centers and state centers with their enthusiasm and their technical knowledge, and who is leading the NHI also. We have Honorary Secretary of Maharashtra State Centre. We welcome you, Pandarkar sir. We have spared your time. The contribution of the ex-chief engineer of the Bombay Municipal Corporation, and he is also a member of our Navi Mumbai Municipal Corporation. He won the election of the Maharashtra State Centre, and he is a convener. I welcome Gadge sir for today's, you have joined us. The program, today we are gathered here because of our organizing secretary, who has put their best efforts to collect all the articles, who has arranged all the experts, technocrats from the industry and academia. I welcome Suresh Babu sir for today's, you have made a wonderful program. I welcome all the dignitaries who is in the audience. They are all highly qualified, highly dignified persons. Some past chairmen are there, some the professors and academia people are there. I welcome you, each one of you, for today's session who has came today. All the participants, I welcome all of you. So why we gathered together today for these sessions? So MMR dominance, Mumbai metropolitan region, has a 77% of India's tall building above 150 meter, and we are ranking around 17th globally. So Navi Mumbai's share is rising is very fast. So today's where we are going to hear from the experts, it is going to enlighten and going to shape the future of the Navi Mumbai. Some of the things which is in current pipeline, the Navi Mumbai has a 25 high-rise towers of 40 plus floors, and 10 completed and 15 under constructions. The key example, Signward Empire towers in the Kharghar at 154 meter and 52 floors, with the completion in 2029. Such a marvelous builders and buildings and technology is coming into the Navi Mumbai. So we have to gear up for that. So all kind of problems which is going to come, we have to start doing research and preparing the solution for those things. The Naina Growth Corridor. Already CIDCO Navi Mumbai Airport influenced and notified area spans 225 square kilometer. The CIDCO has already awarded 2,039 crores for the integrated infrastructure in Naina, TPS 8, 9 and 12. CIDCO AMD Vijay Singhal estimated the NANA development cost is around 25,000 to 30,000 crore potentially, maybe more. The engineering loads, the IS 875 part 3 specifies the basic wind speed for the Mumbai that is going to come around 44 meter per second. That is the critical for our coastal high rises. So we are all situated here in the coastal area where the wind speed is going to become a critical parameter. We have to gear up and design all those parameters, and we will be getting enlightened through our experts today's sessions. Nearly 60% of the Navi Mumbai is on the marine and reclaimed soil. The demanding pile foundation akin to offshore structures. So here another corrosion is going to become another challenge. This is the next zone where the corrosion will be more prone. So all the materials we have to develop in such a way that the sustainability is there and it is long lasting. The maritime high risk. The just 95% of India's trade by volume moves by sea. Our towers move 3 to 5 lakh tons of the materials per 50-story project vertically. We have to understand the potential of that 3 to 5 lakh tons material per 50-story project vertically. And the another is the wind load on the coastal towers, mirror wave forces on the ships. The JNPT's proximity means corrosion protections for the ports informs our affected design. Today's ecosystems, the regulators, CIDCO is developing Thane-based districts, Aero City, Edu City, Medi City near NMIA, all high-rise intensive. So these are some of the areas where the industry like Paradise Life Space signed 3,000 crores MOU with the CIDCO for the NANA. The another partner for the today's Fusitech elevators, the Sapphire Tough, Sezal Group, enable vertical transport and the safety. These are the basic requirement for the safety for the high-rise buildings. They are the partner of the today's event. So definitely they are going to enlighten all the audience. For the knowledge, we have here the experts, Dr. Dilip Sarode sir. He is going to enlighten from the Institute of Chemical Engineering. He is going to enlighten us. Suchita madam is here for the coastal facade, and Dr. Priya Mandirata on the geotech address our realities. If we talk about the IEI commitments, Institution of Engineers is since 1920, IEI has been India's engineering conscience. Navi Mumbai Local Centre is having more than 4,500 corporate members, and we are committed to zero structural failure, and we are also committed for the 30% energy saving in the high rise by 2030. So all these parameters will be definitely helping us to drive the country's movement and make the country again the sustainable by 2030 and 2047 as the vision of the Prime Minister is given to all of us. Friends, with the MIA targeting 90 million passengers per year and the metro line 8 and 9.8 lakh daily passengers by 2031, Navi Mumbai's vertical growth is inevitable. Let's engineer it to be a safe, sustainable and world class. I thank Fusitech, Sapphire Tough, Sezal Group, our knowledge partner and the team of the organizing committee. Everyone who has contributed for this session, who has come here, all the team members, they have meticulously designed the entire program and they have ensured that we all are here. For that, I thanks to all of them for their supports and making this successful. Let's use today to ensure India doesn't just reach new heights, it defines them. Thank you.
you, sir, for the inspiring words and the warm welcome. May I now invite our organizing secretary, Sri Suresh Babu, sir, to give an outline of the vision and the significance of this seminar.
Good morning to all, distinguished guests and my colleagues, students. See, I'm really delighted to be with you with a theme, reaching new heights, overcoming challenges of high-rise construction. Now, in India, I think maybe 1,000 years ago, we had some of the structures as tall as 68 meters, 70 meters, that is 1,000 years back. That is Brihadeshwara temple in Tanjavur. And maybe after Mughal period, then we had a Qutub Minar, slightly taller than that. But after that, I think we have gone much, much behind. When entire world was constructing taller buildings, we kept making smaller building. In fact, in last 200 years, in America and other places, they had several tall buildings. India didn't have even single. And maybe in last 20, 25 years, even Asia, South Asia, Southeast Asia, we had several tall buildings. Still, India was sleeping. And in fact, till 2000, that means end of this century, our tallest building in India were just 20-story or 25-story. Like then after 2000 years, then we started making a smaller tall building. Because initially when Americans made a tall building, like in 1930, when we made a Chrysler building in New York, that is 320 meter high. In 1930, they made the building, and they made exactly, they took for making 320 meter building, they took exactly 1 year, 4 months, and I think 9 days, they completed. That is 100 years ago. Till today, India, after 100 years, even today, we don't have a single structure like 320. There are some structure, they try to make a 320, but they have to stop at a 300 thing, and they took, I think, 20, 25 years to complete those buildings. Because of so many issues, so many problems and other things. And it is not very easy to make this tall building. When you start making a tall building, every meter you go up, our challenge is also going high. And we have challenges in terms of structural stability, then wind pressure, then we have to integrate all the services into the thing, then how to manage the thing, how to manage the entire construction, then material. So many challenges are there. How to overcome these challenges? Only by the collaboration, the fine-tuning, fine collaboration between architects, engineers, policymakers, then only we can create this tall building. When world made the tall building for their passion or their for what is it called, technological advancement, and showing the world, Arey, we are so rich, karke. But in India, especially for Mumbai, it is not for showing. It is the need of the hour. Our 50% of people in Mumbai are living in slums. They don't have a house. How to make the house for everybody? We don't have any other option but to go higher, then only we can make a house for everybody. That is what we are doing. That is what the purpose of today's thing is, bring all the professionals together, decision makers together, and so that we have to create a lot of houses. As per the central government's direction, Maharashtra has to make 30 lakh houses, 3 million houses within another 2-3 years. How will you do that? For that, we require a lot of high-rise buildings. Now, I don't want to, we will be having several sessions today. Several experts are there. They will deliver what is required, where is required, will be there. I hope all of you will be staying back till evening. It will be a really insightful session. I really welcome all of you, and looking forward to a very productive, very insightful session throughout the day. Thank you very much.
Thank you, sir, for outlining the vision and significance of the seminar. We move towards felicitation ceremony. May I request our chairman, SP Singh sir, to please come forward. Volunteers, please help with the and felicitate our guest of honor, Shri Anurag Sinha sir. More volunteers, please join. May I request Shri VC Kamble sir to please felicitate Dr. Shri Bachchu Bhai. May I request Dr. Krishna Kumar Godbole to please come forward to felicitate our next VIP guest, Dr. Deshmukh. May I request Kodbole sir to please be there. Dr. Kodbole sir, please to Dr. Deshmukh. Kodbole sir, one more to Dr. Navnath Gadge sir also, since he's besides you only. May I request Dr. H.M. Raje to please come forward and felicitate Dr. Captain Bhandarkar sir. He is not there. Mr. Om Darak. Sorry. First VC Kamre sir. Then we'll do. May I request Mr. Sanjay Kumar Singh Mahapara? Sorry, Mr. Mahapara sir? Mahapara sir to please come forward and felicitate Dr. Bhandarkar sir.
Honorary Secretary Maharashtra.
Honorable Secretary Maharashtra. Bhandarkar sir. अजून कोण करू सर?
केडी जाधव.
त्यांना बोलू.
केडी जाधवने होऊन दिलं.
बरंच झालं नाही.
केडी जाधवने
May I request Sanjay Kumar Singh sir to please be ready and please felicitate Mr. Om Darak. Om Darak झाले. गोड बोले सर. त्यांना फेलिसिट करायचं ना.
एसपी सिंगला नाही केलं.
एसपी सिंगला नाही केला. मग कोणाला सांगू? तुम्हाला सांगतो ना. May I request Mr. KD Jadhav to please be ready. Please come forward, KD Jadhav.
एसपी सिंगला.
एसपी सिंग सरांचं बोलतो.
केडी जाधव एसपी सिंग.
आणि अजून कोण राहिलं?
सुरेश बाबू.
त्यांना काय सांगू?
चेअरमनला सांग.
चेअरमनला सांगू. सर आपका है. Yes sir, please come. Please felicitate our chairman SP Singh sir first.
बाबू सर.
है ना कुणाला सांगू?
बाबू सरांना. बाबू सरांना चेअरमन सांग. नाहीतर मी सांग. माझं नाव नाही.
तुमचं सांगतो. डॉक्टर गोडपले नाही ना.
नंतर मग चेअरमन करणार. राजेसाहेबांना आणि दोघांना चेअरमन.
आत्ताच करायचं नंतर. May I request Engineer VC Kamre sir to please felicitate our organizing secretary Suresh Babu sir. May I request VC Kamre sir, since you are, please felicitate Priya ma'am, Shri Priya Bendirata ma'am. May I request Shri Ajit Satardekar sir and Dr. Dilip Sarode sir, please to come forward. May I request Suresh Babu sir to please felicitate Dr. Ajit Satardekar, sir, he is here. त्यांचं पण करून टाकू. कोणाला सांगू? हां. Suresh Babu sir, one more. Please, Dr. Dilip Sarode sir, please come. Please felicitate him. Request you to felicitate. Dr. Godbole कोण आहे?
माजी चेअरमन आहे
कुठे आहेत बसले?
राजे सरांच्या बाजूला.
कृष्णकुमार गोडबोले. हाँ, आप आ जाओ सर. May I request SP Singh sir to please felicitate Dr. Godbole, our past chairman. Dr. H.M. Raje sir, please come forward. May I request SP Singh sir to please felicitate Dr. H.M. Raje. Amol Kher. May I request Engineer Amol Kher sir to please come forward. I request SP Singh sir to please come forward. SP Singh ne samvada. Bajaj sir, Prakash Bajaj sir, please come forward. SP Singh sir, one more, please. Please felicitate Prakash Bajaj sir.
बाबू सर.
Suresh Babu. May I request Suresh Babu sir to please come forward and felicitate. आपने एक दिया है सर. Mr. Bhupesh Babu. Mr. Bhupesh Babu, please come forward. May I request Suresh Babu sir to felicitate Shri Bhupesh Babu. सॉवेनियर मी करतो. और किसी का करना है तो अभी. So, may I request the volunteers to please bring the souvenir. We'll move towards releasing of souvenir. Today's special event of releasing the seminar souvenir. May I request the dignitaries to kindly join us for the special moment. पहिला विचार मी करू. स्पीच का करू? स्पीच तू करणारस? आता स्पीच आहे सचिव आहे. त्याच्यानंतर मग मनीष भतीजा आलेच नाही. सॉरी. May I request Shri Purushottam Daijude, sir, to please come forward. Mr. Purushottam. May I request Godbole sir to please, Dr. Godbole sir to please felicitate Shri Purushottam sir.
Let us now move forward with the session. Ladies and gentlemen, it is my privilege to introduce our esteemed special guest, Shri Bachubhai Arithya, Chairman of Akshar Developers. A visionary entrepreneur and a respected name in the real estate industry, Shri Bachubhai established Akshar Group in the year 1995 with a strong commitment towards quality development and customer trust. Under his dynamic leadership, the organization has grown into one of the leading and most trusted real estate developers in Navi Mumbai. Known for delivering landmark residential and commercial developments, Akshar Developer has played a significant role in shaping the urban landscape of the region through thoughtfully planned and high-quality projects. Shri Bachubhai is widely respected for his simplicity, strong values, business foresight, unwavering dedication towards excellence in the real estate sector. May I now request Shri Bachubhai to kindly address the gathering.
थैंक यू। सबसे पहला तो आप सब पढ़े लिखे और मेरे से बुजुर्ग भी, मेरे से अच्छा जो बिल्डिंग किस टाइप की बनती है, बिल्डिंग मेक करने वाले आप सबने मुझे अनपढ़ को यहाँ बुला के मेरा सम्मान किया। इस बारे में मैं जो ऑर्गेनाइज टीम है उसका धन्यवाद करता हूँ। मैं 1995 में एक छोटा सा बिल्डिंग बनाने का ख्वाब सोचा। एक्चुअली मैं एक जे लेबर जॉबर था, जो मैं नवी मुंबई में जो बेकारी काम करते हैं वो मैंने स्टार्ट से किया हुआ है। सो एक मेरा सपना था कि जो हम कंस्ट्रक्ट दे रहे, जो बिल्डिंग बना रहे, वो किस ढंग से होनी चाहिए। सारे डेवलपर्स अच्छा ही काम करते हैं, बट जब भी बिल्डिंग बनानी है, जहाँ जो लोग रहेंगे, जहाँ जो अपना सपने का घर जिसने सोचा होगा, वो उतना जरूर सोचेगा कि मैं जिस बिल्डिंग में जा रहा हूँ वो बिल्डिंग में अच्छी सुविधा हो, अच्छा कंस्ट्रक्शन हो, इंटीरियर के साथ साथ जो बिल्डिंग का पाया मजबूत होता है, जो बिल्डिंग जहाँ से बनती है, हम कहते हैं कि जिस वृक्ष को जो थड़ बोलते हैं, जो जमीन से जुड़ता है, वो अगर मजबूत है, सो बिल्डिंग एक अच्छी तरह से जो हम बिल्डिंग बनाते हैं कोई भी, वो मैक्सिमम इयर्स उसका लाइफ हो, इस टाइप की बनानी चाहिए। ये मेरा एक उसूल था। 2003 में मैंने कुछ हाई राइज बिल्डिंग बनाने का सोचा। सिडको से मुझे एक पाम बीच पे ही एक अच्छा प्लॉट मिल गया। जब मैं ये डिजाइन बनाना स्टार्ट किया, मेरे इंजीनियर्स और मेरे आर्किटेक्चरल दोनों को मैंने ये बताया कि ये मुझे उस वक्त 2003 के समय में जो नवी मुंबई में हाई राइज बिल्डिंग मेजर 14 फ्लोर 15 फ्लोर के आसपास ही बनती थी, रेयर बिल्डिंग 15 फ्लोर के ऊपर थी। सो मैंने सोचा कि ज़्यादा से ज़्यादा हाइट मुझे क्या मिले। मुझे उस वक्त 25 फ्लोर मीन्स 90 मीटर की हाइट मुझे परमिशन दी गई। मेरे आर्किटेक्चरल और इंजीनियर्स को मैंने बताया कि ये बिल्डिंग जो हम बनाने जा रहे हैं वो कॉमर्शियली मतलब प्रॉफिट तो होना ही होना है। कोई प्रोजेक्ट में अगर प्रॉफिट हो या ना हो, बट हमारी बिल्डिंग इस ढंग की होनी चाहिए कि अगला जो हमारा जनरेशन है उसे भी याद करें लोग, उस टाइप की बिल्डिंग होना चाहिए। सो मैंने ये स्टार्ट किया। जब भी हमारे कोई बिल्डर्स जो उनका ही कहना है, उसमें से एक मैं नाम लेना चाहूँगा, महावीर डेवलपर्स। अशोक छाजर जी ने जिस दिन मैंने 2006 में वो बिल्डिंग खड़ी कर दी और उसका जो हैंडओवर दे रहा था, जब भी मैंने सब बिल्डर्स को भी बुलाया था और जो फ्लैट कीपर थे उसको भी बुलाया था। जब भी अशोक जी ने एक मेरे लिए लेटर लेके आए, मैं ये बात इसके लिए कहना चाहता हूँ, कोई तारीफ की बात नहीं है, बट बिल्डिंग किस टाइप की होनी चाहिए। उस वक्त उसने ये बताया था कि हम सारे बिल्डर्स, मतलब जो ओल्ड बिल्डर थे, क्योंकि मैं उस वक्त न्यू बिल्डर था, तो जो ओल्ड बिल्डर हम ये सोचते थे कि एक किराना की पुड़ी बनाने वाला ये 25 फ्लोर का बिल्डिंग क्या बना पाएगा। और उसने लिटरली लेटर लिख के आया कि हम ये बोलते थे, आज हम एप्रिशिएट हुए कि ये किस ढंग की बिल्डिंग बनी है। सो मेरा कहने का तात्पर्य यह है कि जो भी कंस्ट्रक्ट करे, आप तो सब पढ़े लिखे हो, इस फील्ड के माहिर हो, हम तो आपसे सीखते हैं, आपका राय लेते हैं, आपसे पूछते हैं कि किस ढंग से हमें करना चाहिए। और हम कभी भी इंजीनियर्स को पहला छूट दे देते हैं कि स्टील हो या सीमेंट कोई भी ग्रेड का हो, आप अच्छी तरह से यूज करवाइए। एग्जाम्पल की 30 ग्रेड 60 ग्रेड या पर स्क्वायर फीट 6 किलो 7 किलो 8 किलो ये नहीं देखते हुए, जो भी ये मटेरियल लगता है उससे थोड़ा एक्स्ट्रा लगाइए। क्यों कि सेफ्टी लेके जब चलेंगे हम, सेफ्टी क्यों चाहिए, क्योंकि जो ह्यूमन रहते हैं, जो वहाँ रहेंगे, वो अगर सेफ्टी का ध्यान हम नहीं रखेंगे तो बिल्डिंग कितनी भी सुंदर बनाएंगे, कुछ सालों के बाद उसमें कुछ ना कुछ खामी होने लगेगी और कहीं हादसा अपन देखते थे। जैसे कि फायर सिस्टम का, ऐसे हर टाइप का जो ख्याल है वो हमें रखना चाहिए। उस वक्त जो अशोक जी ने बताया कि ये जो बिल्डिंग बनाई है, वो हम एक ये कहना चाहेंगे कि अगर मन में हौसला हो और क्लाइंट के तरफ ही, क्योंकि प्रॉफिट तो होना ही होना है, प्रॉफिट करना है। प्रॉफिट करने की ना हमारे क्लाइंट मना करते हैं, ना कोई करते हैं कि आप प्रॉफिट क्यों ले रहे हैं, लेकिन हम प्रॉफिट ले रहे हैं तो उसके सामने हमें उसको पूरा संतोष देना बिल्डर का काम होता है। उसमें अकेला बिल्डर काम नहीं कर सकता है, साथ साथ में इंजीनियर, आर्किटेक्चरल और सारी टीमें उसमें अगर अच्छी तरह से काम करेगी तो डेफिनेटली जो बिल्डिंग का लाइफ है वो अच्छा खासा रहेगा। दूसरा, ये नवी मुंबई और मुंबई ये थोड़ा ऐसा वर्टिकल क्यों जाना है, क्योंकि लैंड की बहुत कमी है आजकल, और जो सर्विसेज, पार्किंग, अदर्स, ये सब कुछ मायने में रखते हुए हाई राइज बिल्डिंग आज आवश्यक है। आवश्यक इसके लिए भी है कि जो फैसिलिटीज प्रोवाइड करनी है वो अगर लो राइज में हम करेंगे, एफएसआई आजकल बहुत बढ़ गई है, वो एफएसआई को ध्यान में रखते हुए भी हमें जितना ज़्यादा हाई राइज में जाए उतने शहर भी अच्छा दिखेगा, सुंदर भी दिखेगा, और हमें सबको मिलके ये शहर को अगर बनाना है तो एक अच्छी क्वालिटी का बनना चाहिए, ये मेरा मकसद है। और आप सबसे भी रिक्वेस्ट है कि आप के जो भी क्लाइंट हो, आप जिसके भी साथ जुड़ते हो उसके साथ ये शर्त रख के ही जुड़ना चाहिए कि क्वालिटी में कोई कॉम्प्रोमाइज नहीं होगा। धन्यवाद, आप सबने मुझे बुलाया, इसके लिए आप सबका धन्यवाद।
Thank you, sir. Thank you for those enlightening words. Ladies and gentlemen, it is my privilege to introduce Shri Anurag Sinha, Executive Director and the Head of Structural Division at Engineers India Limited, New Delhi. With an illustrious professional experience of over 38 years in the field of civil and structural engineering, Shri Sinha has contributed extensively to several projects of national and international significance across sectors such as hydrocarbon, infrastructure, metallurgy, atomic energy, and space research. Shri Sinha was selected by the Government of India as a technical specialist for the Indian scientific expedition to Antarctica, which reflects his exceptional professional standing and contribution to the engineering fraternity. May I now request Shri Sinha to kindly address the gathering.
A very good morning to all of you. First of all, I take this opportunity to thank the organizers of IEI Navi Mumbai Local Centre for inviting me at this important seminar of the current requirement of our all the metro cities, particularly Mumbai. And the topic of today is very apt: reaching new heights, overcoming high-rise construction challenges. So I'll touch mostly upon the design aspects and little bit about the construction aspects. And today we have an opportunity to gel together with the various who's who in this industry, consultants, architects, developers, and we have some people who have been associated with high-rise construction in Mumbai MMR region. And there will be a brainstorming among the stakeholders. This seminar is, I can say, what better place it could have been than Navi Mumbai for holding this seminar, where it is very much pertinent, as I said, compared to other metro cities of India. And you can say that Navi Mumbai has almost more than 15 plus high rises, you can say tall buildings which are as per codal definition, they are there and upcoming, lot of them are upcoming. Of course, Mumbai has a larger number, and the magnificent view from the Bandra Worli ceiling stands testimony to it. Coming to the topic of why we are going vertical, because as my previous speaker Bachubhai has said that land spaces are becoming scarce. Very much of environmental protection is also required. Green cover is also to be maintained. Natural drainage and topography is also to be maintained. So there is no other option left other than to go vertical, which has its own challenges. The challenges start right from the geotechnical investigation. First of all, selecting the site, again it's a challenge. And then second comes the geotechnical investigation. It has to be in a very proper form. All the details should be covered, because superstructure you can do any retrofitting if required, but foundation one cannot do anything later after it is constructed. Then in the design office, once we get the geotechnical investigation report, the design is made, and more so the involvement of construction team who defines the construction sequence is also very much important, because the design has to suit the construction sequence. Such tall structures cannot be built in single go. Different construction phases will be there. There will be multiple towers interconnecting to each other. There will be various underground basements, like sometimes -4, -5 also. Groundwater table is also a challenge in the coastal regions. And the choice of material, because it's a corrosive area, coastline is always big challenges to avoid the corrosion and mitigate the corrosion rather. So various materials are now available to mitigate that. Also then, once we adopt the construction stage analysis in our designs, softwares are available, tools are available these days, which this type of analysis used to get missed in earlier days, but now it is a must. And then comes the selection of material, which is also very much important. So such high rises are built in hybrid mode of construction. Bottom maybe 1/3 will be of high grade concrete. Then we go for structural steel, maybe a hybrid mode, either concrete filled tubes or structural steel encased in concrete. Then upper ones are in structural steel. So this complex geometry, rather the complex material of this building, also plays a very important role because of various aspects, like we have lot of sway because of wind loads, high wind loads in particular in the coastal region. We have lot of high winds, sometimes cyclones. India coastline is very much exposed to various types of such environmental loads. Of course, seismic is not much, but wind and cyclones are there. So we have to be very particular about considering these aspects, particularly the sway, the horizontal movement of a building, which a person may feel uncomfortable living in that height. These are all taken care by various methods, like currently we have base isolators. I'm not aware of this region, whether these are in practice or not. My friends in the audience can guide me, or on the dais can appraise me on that. Then comes the tuned mass dampers, which are installed at the topmost floor. And also we have jumbo bracings, which I have of course seen in Mumbai region, wherein we have seen the jumbo bracings installed on the outside facade of the building, because interior nobody wants to touch. The interior working spaces has to be maintained as per the requirement. The carpet areas should not be get disturbed, but on the outside facade jumbo bracings are installed, which considerably reduce the sway and the horizontal deflection of the buildings. Again, these days we have heard about lot of modularization, modular concepts, precast 3D volumetric construction, which of course is possible in, say, low range tall buildings of say 25 meters or so, 15 to 25 meters, it is possible. and it saves a lot of construction time. Ready-made 3D volumetric pre-finished sometimes are available. Various manufacturers are there who are making it, and it can be installed. Otherwise, if we don't talk about three-dimensional, which we call PPVC, we can go for two-dimensional panels, floor slabs, wall panels with cutouts and all the MEP embedded inside them. That is available. Then MEP and BIM is the current state-of-the-art technology wherein all the stakeholders are aligned with each other in every phase of the design as well as the construction. The construction progress is also monitored through BIM, and the design stage is also like, generally we have seen that midway of the design, owner will come, he might be visiting some foreign country and he will suggest, I want this, I want that. So mid-scope changes, corrections, improvements are very much there. It is not bad that they are demanding this, but had it been defined in the very initial stage, it could have become easier. But still one has to accommodate those changes also. And so for that, MEP is the solution, BIM is the solution, wherein each and every paisa of your investment can be tracked, the cost impact, the time impact, and the schedule, of course, in three-dimensional one can view. And as I talked about verticality, even a small angle of 1 or 2 degrees can make the structure look, I mean, people will be scared to live in a structure which seems to be tilted by even a 1 degree, because in such a height it shows horizontally tilted structure. So different methods are there, as I said, base isolation, TMD, jumbo bracings, etc. And further, if we talk about, our Honorable Prime Minister has made this housing for all scheme, wherein every Indian person should own a house, and there is a scheme called Pradhan Mantri Awas Yojana Urban for urban, as well as there is for rural, for where different specifications are applicable. So PMAY Urban and Housing for All also are the mandate which we have to honor and provide the dream house to all the citizens of India. So keeping all these challenges, it makes the situation very complex, and as we see, as Bachu Singh sir has been telling, that in foreign countries it has been almost decades back this type of concepts have come, but India, we are lagging behind. Of course code has come, but then it is up to only maybe 250 meters, but now we have seen 300 meter plus buildings. Of course, one building which EIL was involved in, the JNPA building, which was around 300 plus meters, which is now I think installed. Our architect was from AHC, I think sir is there from AHC, so it is now under hold. So that could have been a tallest commercial building, rather 47 stories. So this summarizes my today's takeaway from today's seminar, and I wish the coming sessions will throw more knowledge into this aspect with the distinguished speakers, and we will, I think, if time permits, we'll have question answer sessions also. And yes, it is the right event happening at the right place at the right time. So I wish the seminar all success. Jai Hind, Jai Maharashtra.
Thank you, sir. May I now invite Shri V.D. Pendarkar, sir, to deliver the vote of thanks.
Good morning. It is my proud privilege to propose a vote of thanks when function is coming to an end, one-day seminar on high-rise buildings. I propose vote of thanks on behalf of the Maharashtra State Center and Navi Mumbai Local Centre on this occasion. It is proud privilege to welcome Shri Bhateeja, MD Chairman of Akar Group, and I welcome Anurag Sir, Executive Director of Engineers India Limited, today's chief guest on this function. Ek minute. I'm sorry, Anurag Sinha on this Executive Director on this function. I'm thankful to special guest Manish Bhateeja ji sir, MD Paradise Group. I'm thankful to VC Kamble sir, Maharashtra Chess Chairman. I'm thankful to the council member, our Neelaj Deshmukh sir, Engineer Navnath Gadge, Domdarak sir, all council, MEC committee members, Godbole sir, all past chairmen, Rajesh sir, all the committee members of the Maharashtra State Center and all the committee members and chairman secretaries of the New Mumbai Local Sanctions. I am thankful to all panelists, speakers of the today's function and all the organizers, Engineer Suresh Babu sir, who has taken immense efforts in organizing this function and making it successful for the today's function. I'm thankful to all the engineers and architects who are present on this occasion. I'm thankful to all the media, thankful to all the organizers and staff of the Navi Mumbai Local Centre. Thank you.
Thank you so much. We are towards the end of the inaugural session. May I request all the dignitaries to please sit in the front row. I request all the dignitaries to please stay there for a photograph, for a group photograph. I request the panelists for session 1 to be ready for the panel discussion. Ladies and gentlemen, I kindly request you to settle down before we begin our first technical session of the day. I request the panelists for panel 1 to please come on the dais. Nilab Nagar Senior Principal Architect Hafiz Contractor, Anurag Sinha Executive Director EIL, Dr. Asim Gokarn Harshvansh AGH Landscapes, Mr. Amol Kher, founder and MD at Akbar Abhinav Consultants Private Limited. I think they did that. Nilav Nagar. Oh, I'm so sorry. I request Mr. Anurag Sinha sir and Dr. Asim Gokarn please take their seat on the dais. May I now invite our moderator, Mr. Suresh Babu, founder and principal at Suresh Babu and Partners, to come on the dais. The topic for this insightful panel discussion is Beyond Skyline, creating human-centered tall buildings. As our cities continue to grow vertically, it becomes increasingly important to ensure that high-rise developments remain sustainable, efficient, and people-centric. May I request Mr. Suresh Babu to kindly take the session forward.
Hello. Hello. Thank you, Akshata. Now we are with some of the best people in our industry. We have Neelam Nagar. We have my friend Neelam Nagar, who was with office for I don't know 30, 40, whatever year. Okay, he has done some of the finest building in India. Then we have Mr. Amol K. He's a planner, and he has done a lot of townships, traffic study, and lot of things. And Anurag Sinha sir, you already got introduction. He is in the top management of engineering certificate. And there is my friend Dr. Asim Gupta. She is taking landscape in a different direction. Now, today our subject is reaching new height and solutions for our high-rise construction issues. But construction is one part of the high-rise building because we have technology, we have management, we can go any height. We are already constructed 850 meter building already constructed. There are another building 1 kilometer tall building is being constructed. And technology, with the technology we can do anything. But why we are constructing this building? How we are going to stay there? Whether the people staying there happily, first of all, they have to feel safe. Unless I feel I am safe here, then our life will not be beautiful. We have to be happy. And that is the reason why we are going to discuss, other than the maybe a little bit of technical part also. And we are going to discuss about human part of the high-rise building. How human going to enjoy the that building, how he will be living there, that kind of a thing. Now, I will start with Mr. Neelam. See, our cities are growing vertically. Many residents report feeling socially isolated because when they are staying in slum or in a village or anything, entire community is connected. But when I am going to But when we have our organization and a tall building, we are, or our children are getting away from the nature. Now, as a landscape architect, I wanted to ask you, how should landscape contribute to resilience in tall building?
Good morning, everyone. My name is Dr. Manish. I personally feel that landscape is the first line of defense, okay, for resilience. Reason being that we can have rain gardens which can develop as social spaces where there can be social interaction. We can use biospace for user services. We can create a lot of shared spaces where you can think of getting in with resilience. Generally, when all buildings are designed, if landscape architects can go deep as a start, then the placement of the light component of the landscape becomes a little more easy for us to look at the very rough or looking at the shady areas. Maybe these social layers that we do have about the building can be better utilized and resilience can be achieved. Because I personally feel that achieving resilience, it is not about whether the building will stand strong after the storm, but how much the building will support each other once the storm is past. Because climate adaptation is linked to environment and if we can, and we can definitely design bioengineered products, so we can design those kind of spaces, we can put them in different areas and bring about that kind of resilience that is much required today.
Thank you, Dr. Now, I would like to ask some question and Anurag sir. See, now she was telling about the resilience. Now, I wanted to ask you, how can resilience against earthquake, fire, climate events, and aging infrastructure be integrated from the design stages? Because that is very important because that keeps people like couple.
Yeah, it's a very pertinent question. Like, as I said in my talk before, that as far as construction is concerned, it is very important. Similar importance is to be given to the design stage. Now, as we talk about the resilience towards environmental forces, yes, the building has to be designed for those forces, and rather than just applying empirical or data analysis to be given. And tools are available these days, various software tools are there, and various, you can say, our experts are there who are creating those type of designs. And as coming to the aging infrastructure of these type of buildings, yes, there has to be a provision in the design itself that later on if something is to be done at, say, any 10th floor, it could be done in isolation without disturbing the entire building. So such type of provisions is mandatory to be kept, not much regular or that, but it is required that any defect found or any, as I said, like after what happens after this storm is passed. So any local damage or any local communication has to be addressed then and there at local level, and that provision has to be kept for that. So that way we can mitigate these problems.
Thank you, Anurag sir. Now, in cities, when you have a tall building, there is one major issue is about the parking. Because nowadays everybody have one car, two car, and in a city there is no place to either drive nor parking. Now, this parking is one of the major issue. I would like to ask about it.
among the civil engineers, structural engineers, mechanical engineers, architects. I'm a transportation guy and many of you will be feeling what is the role. So when I look at the high-rise building, I will not get into the definition, but I will look at it as a high-density development. So for an individual building, as far as transportation planning is concerned, the location of maybe entity exits, entity egress, all that should be taken care of properly. Those who have visited Navi Mumbai Municipal Corporation building, they can understand it is only the intersection of aegis and umbrella, but then thousands of people come very smoothly and come out of that building. So similarly, those aspects have to be taken into account. See, as far as the policy changes are concerned, I feel one has to look at the parking norms which have been prescribed. Just to give an example, today about 500 square feet, we give one parking. So let us say if somebody buys 5 such offices, 2,500 square feet, around 100 people working, 10 of them are going to bring in the cars. Let us say 10 to 15%. That is exactly what I was saying when there is a public transport is a very strong proposition, then you will have a modal share of 10 to 15% cars. So that itself is going to generate about 10 to 15 cars, whereas you have only given 4 cars to the owner. All those cars are going to come on the road. Then
back to the native business is very important. And as and when we progress, these kinds of robotic management practices, AI introduced, management of landscapes, or I think this is going to be a part of the culture that is going to set up. And these vertical cars are actually, because we already see the cities, we already see cities in China and Singapore already having those kind of vertical, tall vertical cars which are already green. They have the hydrogen coupled mode, as compared to what we see out here. So I think definitely that is where is the next climate adaptation that is required, and yes, I think planners are thinking about it. I think that is. Thank you.
Thank you, Dr. Aziz. Now we are talking about livability and conservation and everything. Now I wanted to throw some other question. Now, because now technology, material, a lot of advancements are coming. Now, what advancements in material and structural systems are enabling safer and more sustainable tall building? I would like to Anurag sir to answer that.
Yes, choices of material of construction has to be selected right at the beginning of the project. And as you said, most easy available materials are there. High performance concrete, UPVC, which constitutes of grade maybe 100 120, which has reduced consistent. Coupled with reinforcement, we have now seen reinforced bars, which have actually no violence as compared to conventional legacy bars. So this can be used in combination with lower pressure bars such as process. Of course, the concrete is the same, but then the radius is good, so that it becomes similar with both the criteria, high performance, and to get a lot of criteria between both, because the radius of criteria is not the same, so that will be good. And then for rest of the buildings, we can have rated or special disease. Special disease is also available in high grade, high grades, so which we have about academic position. 250 grade is almost how we are with 350 nowadays, 250 grade of steel. And nowadays, steel in the problem is respect to iron. So we are now manufacturers are making fire resistant steel, which can take care of certain amount of resistance to fire, so we can then active mechanism, rotating force, if we can then coming to interiors, like we have NMMC. So again, in NMMC, we have a lot of components which can be assembled together. All the components can be assembled together beautifully. And also, considering the HVAC part and the lighting part, all the new type of fittings are available, and which are there, which can be put into the design of the interiors. Such materials, lightweight materials are there, which is used all over the building, those are there. And of course, yes, to take care of the comfort and the resilience of our equipment. These materials also are in low VOC and they are.
Hello.
Most of the buildings are now measures from agencies. So basically, they are certified or certified buildings. So not like that in the business and good. So these can be integrated buildings.
Thank you, sir. In fact, yesterday I was in one of the precast plant of LLT, and they are entire component, all wall, roof, stair, everything will be assembled, means fabricated in a factory, and it can be taken to the site, and entire construction can
Hello.
be,
Hello.
instead of a year, instead of weeks, they can construct. In fact, I was reading some article, I think in China, 30-story building they completed in 4 days. We can't even complete in 4 years. Anyhow, now I wanted to ask Amol sir, in high-rise building, density development, what are the prerequisites from the transportation point of view? When you have so much of things, what should be the prerequisites?
As I mentioned earlier, when I look at the high-rise, high-density development, I can see maybe 2-3 models. So one is a, let us say, you can say US model, wherein you have a CBD, which is a very high-rise, high-density development, and then people staying in suburbs. And then it is connected by strong transportation corridors. Either maybe you can say underground tunnels, or maybe the tube. So when we talk about the Chrysler building, which was constructed in 1930, metro was already present in New York in 1900. So that is what I say a prerequisite. If you see our Indian model versus Singapore model, the Singapore, they have done a very compact kind of a high-rise, high-density development, wherein everything is woven very strongly around the public transportation network, and there is much of a very much little dependence on the cars. When it comes to India, we started with I think US model, and after that it gone into some kind of a khichdi. So first Nariman Point, if you look at even for only for the Bombay Nariman Point, they developed it as a US model with a strong railheads of Western and Central Harbour Railway at VT and Churchgate Station, very convenient way to work as far as the public transportation is concerned. But then suddenly BKC comes up without much thought on the public transportation. Now whatever is being developed as a metro or a PRTS in BKC, I think it's all afterthoughts. In their master plan, there was no space left for the station where the metro station is going to come, where the PRTS station is going to come, and then what we are trying to do is, to mitigate the measures of high-rise, high-density development transportation corridor. So I feel a prerequisite is a very strong transportation network if you want to get into the high-rise, high-density development. At the same time, address to the last mile connectivity. Now look at the Saifi Buraddin Trust development which is happening in Bhendi Bazaar. Such a huge high-rise, high-density development without much connectivity to the public transportation. So we were working with them. The nearest station, metro station, Aqualine 3 and Aqualine 4, they are 700 to 800 meters away from them. But still, last mile connectivity has not been thought about. At the same time, very little thought on the public transportation system. So the problem is, even now the Orange Gate to Coastal Road tunnel connectivity just touching the SBUT development, but then there is no up and down ramps which are given to the SBUT. So all these things, external connectivity, transportation network, strong public transportation facilities, these are I think some of the prerequisites which has to be looked at before we assign anything to with a very high FSI, maybe 4, 5 or 10 FSI. So these are the things I think we'll have to look at.
I think if I correlate all these topics which we have in the panel today, there is one project in Saudi Arabia, the line, the NIAM project, which contains everything. No cars, lot of greenery, within, it's a city, sort of. And now, of course, the length is reduced from 2.7 kilometers. They are building now 200 as a proof of concept. in a demonstration mode. Let us see what happens to it, but it's worth studying.
I think that this discussion, there is no end, because such expert, it can keep on going, but we have some time limitation. Now I will ask one common question to all of you and to end this session, because generally success in high-rise project often measured by height, density, efficiency. That is the general practice. But I wanted to ask, should developer and policymakers also evaluate buildings based on social well-being, community engagement, and resident happiness? And if so, how can these outcomes be measured? Height I can measure, and density I can measure. How the happiness and social this thing can be measured? A simple, all of you can give a very short answer.
So I think it's a very important question. Because we have a tendency of measuring everything by green square meters. Right? So much square meters is green. But I think now that needs to change, because it's not only that green square meters that matters, but maybe what is the biodiversity index of that particular building. So when I say biodiversity index, how many native species have you incorporated? Okay? Do we really need just a well-manicured landscape, or we need something that is more sustainable? How many pollinating species have we actually introduced? Because people are very social, right? And we would like to see butterflies, we would like to see seasonal variations in the buildings that we live in. So I think that can be one measure. Another measure can be, as you said, rightly said, about the biometrics, the movement wellness index. Because when you're closer to nature, a lot of things, like your stress levels, cortisol levels go down. More brighter light, like instead of having covered alleys, maybe you can have something which is allowing the daylight to come inside. Because all this will definitely increase the cognitive capacity of humans. So I think that is also very, very important. And with that, as we go ahead, these metrics, because we have sensors today to detect the temperature, right? A simple temperature assessment of what can be the temperature of the area inside and the area outside. How is the ventilation affecting that? So all these, I think, are parameters that need to be assessed, and that will really make our buildings more smarter, more livable, and people will really live the happiness index of properties. That's what I think.
Yeah, regarding the social aspect, as Indians are known for traveling a lot. So now in the case of high-rises and density, not being the same complex, but traveling, they will still travel to like kilometers. Today, when they go to Nala or they go to Nala, there's a typical solution that so that's outside the complex is social aspect. Within it is
See, from transportation point of view, I think the measure can be my children go to school or college within maybe 15 minutes to 30 minutes. I go to office maybe within half an hour. I go to any part of the city within 1 hour for my social trips. And I am able to come in and come out of the complex with no time, no queues. I think that can be the measure for success in the building transportation.
Yeah. Hello. Yeah. So I think I quite agree with the idea that this if you want to have high density urban habitat, transit oriented development is the way forward. Now that is an old word. Now recently I was in Japan where they coined the term transit integrated development. It is no longer about you don't orient yourself anymore. You have to integrate yourself with the whole idea of a transit integrated development. So they have come up with models which, like you said, one is of course being able to go to school, college, office, work, recreation, and this thing is to go there and to be able to meet and come back, and that's and the time taken for doing it it greatly enhances the way you interact with the people and do everything else. What they have also integrated in that, in the sense that they have taken it one step ahead of what Singapore does of creating the green space index. So they have integrated to make sure that this entire corridors are also fairly nature friendly in their thing. So I guess there is somewhere in between where you get a good transit integrated development merged with the greenery is where I think the future of urban spaces lie. Thank you.
So I think this is just one more thing that I'd like to mention here, that in creating those green spaces, which you're trying to integrate in whatever urban fabric that you have, are they unused or are they ecological dead? That is what we need to know.
Okay. Thank you, Doctor. I think we had a wonderful exchange of ideas, point of view, and actually we wanted to continue much more. Because of time, we have to stop it here. But this kind of dialogue and conversation will keep happening. We are conducting several seminars like this, and that's it. And the thing is, today's specialty is we are all from a different background: architectural background, transportation planning background, engineering background, and landscaping background. And for a success of any project, we have to integrate, we have to collaborate, everybody. Then we can have a wonderful project. We can solve so many issues what we are facing today. Thank you very much. Thank you everybody for this wonderful panel discussion, and thank you for the audience. Thank you. Sir, 1 minute.
May I request Chairman SP Singh sir to felicitate the panel. Dr. Asim Gokarn. Mr. Anurag Sinha. Mr. Amol Kher, founder and MD at Akar Abhinav Consultants Private Limited. Mr. Nilab Nagar, Senior Principal at Architect Hafiz Contractor. And our session moderator, Mr. Suresh Babu. Thank you to our respected moderator and distinguished panelists for such an engaging and thought-provoking discussion. We shall now proceed to our next technical presentation. It gives me immense pleasure to invite Mr. Hussain Akbar Ali Rampurawala for his presentation on the topic Importance of Facade and Glass in High-Rise Buildings. The facade of a building plays a vital role in defining not only the architectural identity of a structure, but also its energy efficiency, occupant comfort, and overall performance. We look forward to gaining valuable insights from the speaker's expertise and experience in this field.
Good afternoon, everyone. Am I too loud? Is it better? Okay. Good afternoon, everyone. I am Hussain Rampurawala, Director of Sapphire Glass Solutions Private Limited. As high-rise buildings are shaping up our city skyline, I am taking up this topic of glass facades and engineering performance in high-rise buildings. Small changes often make big differences. That is what I have tried to show in this presentation with some relatable pictures and examples. In high-rise constructions, facade is not just an aesthetic element. It is a very critical system. It has to withstand extreme environmental conditions, ensure occupant comfort, and contribute to the building's structural integrity. As floors go on increasing, the demand on the facade escalates dramatically. Every facade design of a high-rise glass building, whether it be a commercial or residential, directly impacts the aesthetics of not just that building itself, but its entire surrounding area. There are two ways of executing a building's facade. One, follow basic standards, or rightly specified facade designing. A facade will surely be made in both cases, but let's see how the end result differs. Following basic standards will result into heat gain and glare issues that directly impact energy bills of the building for its lifetime. Here is an example of a prominent hotel in our city. As you can see, due to wrong choice of glass, almost entire building is using curtains or blinds. What's the point of choosing a higher floor when you cannot even enjoy the view without having a migraine? In the last 2 decades of my work experience, I have come across several buildings and offices that look and function very well during rest of the year, except for monsoons. Water drips from several places within the building. I'm sure many people have the same experience when we go to such offices. And the surprising factor is that these buildings are not more than 10 years, 12 years, in some cases 5 to 6 years itself. So the reasons are poor quality of sealants and in most cases absence of a facade consultant in the project execution. Occupant comfort, according to me, should be put ahead of everything else. Here is an example of another building in our city. Mostly in curtains, reason again wrong choice of glass. Excess light coming through lets in excess heat and glare also, resulting into interiors heating up and electricity bills shooting up. Here is an example of a comparison between basic and a rightly specified facade. The building on the left uses clear glass for its windows and balconies and railings, resulting into zero privacy, and the building on the right uses a performance glass in its windows and balcony railings also. The result is that the building on the right has full privacy, heat insulation, UV protection, and comfortable living conditions. My question to everyone sitting here is, where would you be more comfortable living? In the left building or the right building? You cannot even access and stand comfortably in a clear railing balcony that you have over here. What's the point of it? People will put clothes to dry and it will be visible from ground floor itself. And where the balconies are performance glass, people will be very comfortable sitting inside their balconies and inside their homes, and they have 100% privacy as well. A standard specified glass building may meet basic codes and standards, but only for a minimum compliance. In simple words, the building's facade is designed to perform just for the present and not for the future. This it also is very common in our city. In the last few slides, we saw the problems regarding facades. Let's see how can we avoid such problems without escalating costs. There are totally 5 key stakeholders in facade designing and execution. Let's meet them. The first, the developer, the person with the dream. Second is the architect, who is the designer of the project. Third is the facade consultant. The facade consultant is the one who visits factories of suppliers and shares suggestions to the developers. Facade consultants are responsible for calculating wind load, weather conditions, and accordingly put the specification in place, and much more and many more things. The fourth is a facade fabricator. The facade fabricator is the one who assembles and installs the entire facade, whether it be residential or commercial. And fifth, glass processor. The glass processor is responsible for the aesthetics and life of each and every glass panels, because silicon used, primary sealants used, all these things will result into the life of the buildings. My recommended approach would be that the developer should involve a facade consultant during the finalizing stages of the design with the architect itself, because involving a facade consultant at this stage would take care of all the facade related complications that would arise otherwise, like costly redesigning processes during facade execution. This is an extremely common situation where architects and developers together finalize a design, and at a very later stage a consultant is brought on board, the facade consultant who is responsible for executing the entire glass facade. The problem happens is, as he is entering very late, the complexities on site and in weather conditions, the rain conditions, the wind load in that particular region will impact the comfort and everything else also of the residents tomorrow living. But due to the consultant coming late on the picture, these things have already been decided. And then there is a compromise. And the compromise is of a lifetime for the consumer to be living in that house, or that person to be having an office working space in that building. And such redesigning costs obviously cost a lot of financial losses as well as time loss for the developer. A facade consultant also helps in glass selections that results in more energy efficiency and sustainability for the structure. Just the right choice of glass in today's world can drastically change living or working conditions. Let's see what are the risks of not hiring a facade consultant or taking him even at a later stage. Incorrect facade system selections, water leakages and thermal issues, fire safety non-compliances, higher maintenance cost, coordination failures between teams that are your facade fabricator, your glass producer, your glass fabricator, your glass processor also, and many more units that are involved in entirely completing the job. Now coming to the facade fabricator. The facade fabricator is the Spider-Man of every building story. They convert facade designs into executable systems and are responsible for fabrication and installation of facades. Getting a facade fabricator on board at the right time of the project is very important. Their opinion is crucial as they face ground realities on site, and inconvenience to them would again cause project delays. Then comes the glass processor. The glass processor is the bespoke tailor of your project, because whatever he is going to process, that is exactly how your building is going to look for the rest of its life. The waves, the distortions, the edge lifts, aesthetic value, as well as it destroys the life of the panel. The glass processor processes raw flat glass into architectural safety glass. It is at their factory that the glass is heated up to almost 700 degrees and suddenly cooled in a controlled environment to temper it. They make double glaze units, DGUs, that is a very common word, laminated glasses as well, curved laminated, curved DGU, all these are being produced here itself now. The glass processor is responsible for the life of each and every glass panels that adorns the building's exteriors. The glass processor plays a very important role in the building, in how the building will look aesthetically for the rest of its life. High-rise buildings require latest technologies for glass processing. Wind pressures and extreme intense heat during days or lashing monsoons are harsh testing conditions. Advanced dual-chamber technologies for tempering lines from European origin for DGU and laminating processes that can handle today's technology glasses is the need of the hour. My advice in every project has always been the same, and it's please visit the factories of glass processors and your facade fabricators, because visiting the kitchen of the people where the food is going to be cooked will make sure and ensure that your work is done smoothly tomorrow without any hassles. Visiting two factories can help eliminate facade problems. One is the facade fabricator and the glass processor. Visiting their premises will ensure their capacities and capabilities. It also answers many questions regarding the machines and their makes that they are going to be used to build your facade. High-rise facades are not just about glass. They are a result of designers, engineers, processing, execution, and a collaborative effort. When these 5 people join the same thinking table at the right time, a lot of magic can happen. When the right stakeholders align, facade performs for decades. I hope I have kept it short and to the point. Thank you for being such a great audience. It's so hot over here. Yeah, I think the spotlight is making it crazy.
Thank you so much, sir. May I request Chairman VC Kamble, sir, to kindly felicitate Mr. Hussain Rampurawala. We now move ahead to our next speaker. It is my honor to invite Architect Ruta S. Pawar, Associate Professor at Bharati Vidyapeeth College of Architecture, Navi Mumbai, to deliver her presentation on the topic Scanned to BIM, Emerging Technology, Risk and Safety Management. Okay. May I request ma'am to please kindly address the gathering with her presentation.
Hello all. I'm being an architect, it's going to be in kind of a different aspects and all perspectives what are going to be considered in case of the presentations. And I obliged that Indian Institute of Architects, the altogether different forum, has invited me as a speaker. So I first thank them and start with the presentation. Basically, I'm going to speak about the safety and risk management into the high-rise building. Everybody is aware about that risk and safety we can't compromise with, and that is the main important factor. If people are added into the seminar, that is the main aspect of any of the presentation. So when I'm going to start about the presentation, there are some of the links of the photos, what one can go for, and one can understand when we say about safety and risk, means people are working at whatever level height, and that's the risk factor. One has to see to it is involved into the kind of constructions what we are looking and what we are talking about today. So when we say about the high rise, obviously there are some kind of other kind of skills, a kind of worker which is expected, and maybe an architect and the supervisor also is expected to be gone through. First of all, we have to understand what we call it as a high-rise, because according to the different aspects of high-rise, maybe the definition for engineers, definition for architects, definition for fire department, definition of earthquake engineers, and facade management also, the definition of the high-rise is going to be changed, and one has to understand we are not at par with the definition of high-rise at international level. So when we consider about high-rise, we consider a 23 meter or whatever is at national level or international level is a high-rise. But in case of our situation, we consider only 15 meter or 50 feet is high-rise. But now the terms of 50 feet or high-rise are changing. And when you consider the skyline of Mumbai, there are so many buildings which are more than 15 meter. So the terminology of high-rise needs to be changed, which has not changed till date, because we still consider that fire ladder, if reaches, is a high-rise. And that needs to be changed from the aspect of the regulations. One has to see to it. Why we are actually speaking about the topic called as safety and risk? Because when we see about the rapid urbanization and the kind of the need of the population increase and the kind of the scope or the pace at which we are construction happening, one has to see to it that that race is too much and that particular risk is too high. Because when we consider about the construction of a Burj Khalifa, it's a 828 meter, and maybe that was a kind of a miracle at that time. And then now we consider that there are buildings which are happening 1 kilometer in height. We consider as 1,000 meter, but when we consider into the kilometer construction, it's 1 kilometer high building which are coming and may be happening. And when we consider about the height and what we have the parameter of the risk, like people has to work to that height. So that harnessing and the risk factor are going to be an important factors in considerations. So these are some of the skylines which are changing into the present perspectives. And when we consider about the safety manners, this is a very old image. One has to see to it. They call it as a lunch on skyscraper. Way back in 1932, in New York, this kind of picture got shot. And when we consider about this image, they call it as a lunch on skyscraper. It was a kind of a publicity stunt to promote livings into the high rise. So it's a very old story of maybe fascination to the high-rise living conditions. And one has to understand when we started the race from 1932, when actually post-industrialization, when the concrete came into the picture and that race of high-rise and the mass construction started. So way back that time, it was at 850 feet. 850 feet, the particular photo was taken, and you can see the workers are enjoying sitting on that beam without any kind of harness. So that was kind of what we also see nowadays, social medias and all that, people are taking these kind of risks, and then you know it's at the cost of their life. One has to understand. So when we consider about the safety parameters, there are certain kind of considerations from building design point, structural resilience, disaster preparedness, emergency evacuation, hazards in construction, fire safety, surveillance, and occupant protection, what we consider as a last, but it's not the least approach one has to consider. When we consider about the building design, we have to see to it that particular serviceability, stability, human comfort. Once again, we are making the buildings for humans to occupy. So one has to see to it that that is a kind of a habitable building. So vertical communication, wind resilience, climate aspects, which we are actually considering now as a prime factor, needs to be considered while designing a high-rise construction. And one more aspect, the material selection, what we are actually missing on to that, what we have seen in the earlier presentation also, we have this monotone or mono or prototype of construction what we are looking at today's presentations or maybe today's skyline. And one has to see to it that skylines or the high-rise could be of different materials also, which are more sustainable and more responding to the climates. And last but not least, part of your design is aesthetical and facade, as the previous presentation highlighted. Now there are certain kind of technological adoptions also, as we have BIM in considerations, and maybe there are CFDs, like computation. These are mandates and people are doing this pre-modeling of your building, and the performance mapping is done at the initial stages only. So they see to it that risk of construction of these buildings should not take in kind of phase of construction, and that needs to be understood. So these are some of the pictures where we have some kind of consideration, and that is a kind of the cross-section of building what normally we see. Structural resilience, when we consider, I know I'm standing in front of engineers, so I should not speak about these, but then there are certain images when we consider about the considerations of structural resilience with respect to high-rise. And these are some kind of core structural systems and the grids what normally one has to see. But once again, see to it that that needs to be up to the right or up to the demand of the codal provisions also what we are expecting into the today's era. So efficiency into the constructions and labor. What is the main important factor is the people are working at that height and their safety and considerations, while considerations of your structure needs to be seen. So like your dead wet, the live load also, construction phase load also. There are certain kind of lateral aspects also one has to see to it. So precise designs, the durability, the code and standard up to the mark, and efficiency into the construction are the prime considerations into your structural resilience. And then further part comes as your capacity to withstand and recover. So whenever we are considering about the structural things, one has to see to it there should be some kind of structural audits and third-party inspections. Because when we go to that particular height, we can't take a risk, and that one has to understand. So when we go for a third-party kind of inspections, and like how we have fire audits, if we do the structural audits, that is an important aspect one has to consider, and that makes sure that what quality of construction. Because see, when we design to the best, but how it gets constructed, that is also a kind of the bridge what is missing between the structural engineer and the kind of the construction what is happening on site. Nowadays people are maybe providing some kind of modular constructions and high performance concrete into the pictures for your high-rise consideration, but it's not a compulsion by the coded provision that you have to go for these kind of systems. So that is a kind of a gap between the industry, what we are talking about the codes, and what is the execution, what happens. When we consider about disaster, I know there were some kind of incidents after the Bhuj earthquake. This picture of disaster preparedness came into the existence. Before that, there were hardly any kind of consideration of disaster preparedness because people were not aware about that. Maybe disaster can happen next to your doorsteps. We were not. Nowadays, we are actually pro into that and do some kind of then. If we consider about the tsunami and cyclone also, we say that, okay, we are into India, we don't have these kind of concepts of disaster. But then the flood what we have faced, Mumbai floods, the kind of the disaster and tsunamis also are not known to us. But if we are proactive, imagine I say that when we are into the picture of building, we have to be more serious than a doctor. Because if I give a doctor give one tablet wrong to a patient, maybe it's impact to one patient. But imagine if we are considering a 100-story tower, what occupancy we are actually playing with. And that's the risk factor one has to understand. That's the seriousness what one has to understand about the risk management and safety concerns. So there are a certain kind of blast and fire considered. Fire is a normal what we consider, but blast we have not prepared for, or what we have not considered in case of your high rise. But in case of 9/11, we were not known that blast also can be a common in case of the areas which are not known to. So these disasters don't bang on to your buildings. They peep in maybe very silently and destruct to a maximum level, and that one has to consider. So there are certain kind of the examples from abroad. Definitely we don't go for, still we are prone into the areas of earthquake, but we don't go for the systems called as dampers. So there are certain kind of miracles which are happened. Taipei 101 tower is the kind of the challenge what Taiwan has taken. Having so much prone to earthquake, they have gone to the height of maybe 520 meter, 545 meter, and then they have created these. And then that building has maybe faced the earthquake also in last 3 to 4 years. And that needs to be taken to that consideration, that have that courage to design the building for your disasters also. And that preparedness is once again expected. So these are some of the kind of basic understanding also. Disaster can't be just the fire, blast, or maybe the kind of earthquake and all that. There are some minor disasters also which can create some impact onto your building. There are certain kind of important aspect with respect to sustainability also. So urban runoff and heat islands. Nowadays we are maybe facing this heat concept. Last 1 month people have said, oh my God, बहुत ज़्यादा गर्मी है, बहुत ज़्यादा गर्मी. It's because of this urban heat island. And they are creating problems to your microclimate. So disaster can be at higher level. It is the slow poison which is actually mixing into your day-to-day life and then will create or bang effect on one fine day. And that needs to be understood. And there are certain situations of the small amount of consideration for your lighting and cyclones also. And building formations needs to be done accordingly. Fire, everybody is aware about. We have a separate code of or chapter under NBC 2016, and it speaks about the huge amount of the evacuation strategies, the emergency exits, responses in case of fire, and we are prone into that. But then the one thing what we actually forget is the mock drills. You have to be updated. You can't say that, okay, I'm prepared for the fire, there are no chances of fire. No, you have to have rigorous mock drills, and maybe a kind of awareness is more important. So these are some of the aspects, and these are some of the models which are actually add-ons to your emergency exit we can consider. When we consider about this, there are hazards during the construction. It's not at the time of building only, it's during the constructions also. And nowadays, if we are looking into the kind of incidents what are happening, we are not actually looking for a broader perspective, because here we least consider is बहुत ज़्यादा population है, so we are least consider about the human lives, and that threat is not taken into considerations. So personal protection kit is PPE, what one has to be mandatorily followed at the particular sites, are not known and not maybe taken care by people. And once again, there are some incidents when we consider about these crane incidents, crane failure, maybe construction falls, scaffolding falls, maybe there are certain kind of open shafts in the case of your construction phase. There are no harnesses which are taken care, and lack of the safety nets and grids, whatever once again needs to be considered, are not taken care into the safety parameters. Now these are some of the kind of the statistics when we consider about, this is by Occupational Safety Health Administration at international level. So they have said that industry of construction, building construction industry is highly having these kind of incidents, and we have not prepared for that kind of things. So there are certain kind of acts for worker insurance and employee compensations. We have not come across because we have not faced these kind of issues. So one has to understand that there are some acts which are working for the workers also. Last but not least, as I said, occupants protection is the prime factor we have to see to it. There are certain kind of, so in right side image you can see, the right side lower image, we can see that there are some kind of AI operator system. Now when we see about the automatic understanding, so you get the scanning of that particular picture or photos, and you can get to know that if that person is wearing a helmet, you know, in Indian psychology, they wear the helmet, but the kind of the particular holding of that particular helmets or maybe wearing it properly is not happening. So you get these kind of impacts also, and the messages also. That person has maybe has used that particular harness, but it's not proper way of handling that harness. So you have these kind of systems one can go for. So in case of advanced construction and these kind of simulations where you can get these kind of softwares where all these kind of systems are available in the market. Only thing is if you use it commonly, because in our area we don't have certification for the labors. In case of your international practice, there are certain certified laborers which are working on the high-rise systems. There are not common laborers which are working at the high-rise, because the kind of handling of the material, the kind of the harnesses, how they have to use is not trained. They are not trained for that, and one has to see to it that particular things needs to be worked in a particular fashion only. So drone inspections, AI monitoring is a common nowadays, and that awareness and training session needs to be done to that particular user group or maybe the kind of the workers on your site needs to be done. These are some of the kind of the areas where you can see there are some kind of mobile apps onto your management systems also, building management systems. So when you see there are apps which can handle the site and post occupancy of your buildings in proper way. We have to see to it that these real-time monitoring and early warning systems. So before your risk, there are some intimations, so pre-intimations are happening. And as I said, the real-time monitoring also is a nice aspect one has to see to it, that if system is at place, is it working properly? We do have a fire ducts, we do have the riser systems, but at the time of once fine day, if there is a fire and we haven't used till date, we don't know are they really working or not. And then we say that we are not prepared for these things, and that needs to be considered. So these are some modeling which are AI and cloud-based modeling people are following. And this is the kind of the development what we are expecting. So when we consider about safety and risk, the important aspect is what we are looking for a sustainable development. That sustainable development is a prime consideration. Your building design, operations, and construction practices needs to be sustainable, environment friendly, and energy efficient. And that is what we are expecting as a prime factor for today's generation. Because when we say that our future generations should reside into this building, we have to create that environment which is comfortable for the next generations as well. So whatever we are doing, any of the building needs to have harmonization between human activity and the nature. And that is the prime considerations of your. So these all are the kind of the reference which I have used. And last but not least, when safety is first, you last. Last means you will get there. So if you prefer a safety, you will last long. That is the main criteria one has to think about, and don't compromise onto it. Because it's existence of your own things, and that is what needs to be always a prime factor of consideration in any of the construction. It's not construction, it's any of the industry and professions what you are following. Thank you all for your patience and listening. Thank you.
Thank you so much, ma'am. May I request Dr. Nilesh Deshmukh to kindly felicitate Thank you so much, ma'am. We now invite our next speaker, Mr. Zishan Mubashir, founder and director of CapTech, for his presentation on building services technology and digital transformation. Digital transformation is reshaping the construction and infrastructure sector by improving efficiency, coordination, and operational performance. We look forward to hearing the speaker's valuable perspectives on this important subject. See you later.
So, good afternoon, everyone. My name is Zishan, and by profession, I am a mechanical engineer. And I got this opportunity to speak on this forum. First of all, I would like to thank architect Suresh Babu for inviting me on such a great forum. And he said, I'm just 2 minutes away from this premises, Institute of Engineers, and he said, "Bhai, Baba, tumko aana hai." So I accepted, and thank you again for this wonderful opportunity. Being a mechanical engineer, having a background of around 15 to 20 years of experience into HVAC, MEP consultancy, moving to the digital platform, it's always been a very challenging task from going from traditional work to the digital work. But yeah, this is what is needed, this is what is required, this is what the industry is demanding. So if you see, in India, we are still following our traditional methodology of doing the work in terms of providing the drawings, in terms of producing the services, the layouts. We are still following the traditional era. But we need to understand what the industry is demanding now. We need to understand where the industry is going, and we have to adopt that. And this adaptation will come from not only the engineers who are working, not only the architect, it has to come from the very basic level, from the colleges, schools, and the institution like this, who has to speak, who has to educate, and make our people trained in this segment. So if we see, our traditional era was like manual calculation, doing the design in 2D. Now it has changed to the current era, and we are talking about the BIM-enabled design. Everything has shifted to 3D, from 2D to 3D. And 3D is not a tool. It's not only a software. We are talking about the process. We have to follow that process. And what is the future? Future era, we are talking about digital twins. We are talking about AI-driven operations. So that will come. That will come. And it is coming. The way the evolution is happening, the way AI is taking care of everything, that will come for sure. So we have to leave this, first of all, traditional era from the manual calculation, because if we are shifting from 2D to 3D, everything is performance based. Our designs are performance based. We don't have to go and check the data book. We don't have to, it's all there. We have to think beyond that. We have to think in terms of making sustainable. We have to think in terms of making performance based building. So the current era demanding is shift from 2D to 3D, definitely. What is this shift is called? We are talking about the process. We are talking about the process from design to the delivery. When I say delivery, it is end user we are talking about. It should help the end users. So आज मैं जो डिज़ाइन कर रहा हूँ और जो मेरा परफॉर्मेंस है, जो मेरा एंड यूज़र को जो फ़ायदा हो रहा है, is it that visible or not? So that we are talking right now. So I'll just break it in 3 parts. One is design, then it's construction, and then what is the post-construction look like. So I'll present some of the case studies also which we are doing in our projects and how we are executing such kind of projects by using these digital technologies and with the help of our engineering expertise. So we are talking about smart intelligence building. We are talking about IoT based building. So data driven decisions. We are talking about that. So that's the current era. Future is beyond and future is near. We are talking about digital twin. So digital twin is a model. You are talking to the building virtually before constructing it. So you are going to see the performance of the building before you are going to construct, in terms of sustainability, in terms of optimization of the facade, in terms of your architecture layouts, the shading, the sun path, in terms of your performance of the MEP services, your load pattern, everything. Why digital transformation matters? Yes, it matters because it's becoming very complex, day by day, increasing the complexity. We have, we have shortage of the skilled laborers. So the digitalization will help during the construction. This digitalization will help how the construction should become a very fast. How we are going to save the time. Everything is dependent on the time, and time is directly proportional to the cost. So we are talking about that. In today's era, time is the only essence which we are talking about. Energy regulations, we are having a sustainability targets. We are setting up, India is setting up the target for 2070, and globally everyone is setting the target for carbon neutral by 2050. So how is that possible? Without this evolution, it's not possible. We have to go digital. So our building should be smart enough. They should speak by themselves. So we are talking about the future. We are talking about the future. Future building should be AI-driven buildings. They themselves get the rectification of the operations. Let's say आपका chiller है, chiller का एक system खराब हो गया, and it will auto detect the performance and bypass it and send the message to the operator and the manufacturer for the maintenance. That is called the maintenance schedule. So we will talk about that. So this is the digital transformation we are talking about, and it is without the people, process and the technology, it is not possible. So we have to integrate everything in one plate, otherwise it's not possible. So we have to adopt. So learning is first. Second is, yes, we have to be very much aware of what digital technology which is coming in. We have to adopt in our system, in our design. First of all is the acceptance. So acceptance is one which everyone, either developer or architect or engineers, everyone has to accept it, and it has to be delivered in that way. So if we talk about the life cycle of this digital building, I can say from the planning stage, it starts from the initial stage of the concept, when you do the conceptualization of the planning, and it goes to the end user when you are operating the building, and it will give the result driven. We are talking about, nowadays government is talking about COBE. How many of you know about the COBE? Construction Operation Building Information Model. Every project which is 40 crore and above will have to comply with the COBE document. So COBE is nothing but it's a XML file which will have your complete asset of your building with the manufacturing details, with the warranties, with the guarantees. It will have a maintenance schedule, everything on a one click. If you click on the asset, you will get the entire data of that asset, and you will have the record also. What is the past maintenance you have done? What is the future which is scheduled? Not about only the maintenance. It's talk about the performance. It talk about the energy efficiency, everything. When we talk about the foundations, so BIM, so in present era, if we talk about the transformation of digital, BIM has given the platform, and BIM has evolved in doing the digitalization of this. Now we are talking about beyond BIM. BIM is just, we are talking about 3D, everyone will talk about Revit. We are not talking about Revit. We are talking about the process. We are talking about virtual construction and design. What does that means? So before that, I'll just quickly run through what is the process of this BIM we are talking about. So we are at first stage. As of now, maximum 70% of the people, we talk about 3D. We talk about 3D only for the visualization. It's not about visualization only. We have to track the time schedule. We have to see the cost estimation. We have to see the sustainability guidelines and the facility management. So that becomes a cycle for any building, any high-rise building or low-rise building. That's become a cycle for any building to become a healthier building. So how to execute this, we have a BIM execution planning which helps executing the entire process. So it's a document which represent about how the construction should follow, what is the schedule, what is the timeline, who is the responsible person. So this is the document which is used. So first step is the coordination. Let's talk about design. First, design is design coordination. So a lot of the time we found clashes when the GFC is gone. At the time of GFC or shop drawing level, we find a lot of clashes which takes another 1 month, 2 months time to resolve, and we lost. By the time we lose the time. In scenario like Mumbai, where 4 months the rain is there, everyone is like from March onwards, we have to be in hurry for the construction. So this delay process will definitely this process will help in making the design smooth, and we will help a lot of the time and the changes which is happening on the site. So this will help a lot. I'll give the examples also. So we are talking about virtual design and construction. What is virtual design and construction? We are talking about the process which we are making virtually. जो भी हमारा साइट पे काम होने वाला है, we have to think in that direction. हमको कॉन्ट्रैक्टर माइंड से सोचना पड़ेगा, डिजाइनर माइंड से निकालना पड़ेगा. We have to think in that direction. We have to think in virtual contracting way. So if you are thinking as a virtual contractor, then you can make a process smooth. So this will help in making a process. So definitely this is the difference which I wanted to tell. BIM has a design and construction focus process where dynamic digital twin is a process where actual replica of the building can be made by the real-time IoT feeds, by the focus on occupancy, dynamic fluid of the variations. So a lot of the things can be possible. So I'll just, so what is the construction methodology we follow in our daily routine? We follow from concept, we go to schematic, detailed design, we submit the tenders, we submit the GFC, we appoint the contractor. So if we are thinking in a virtual design and construction bay, so you have to come into the picture before freezing the design. So during the design stage, the review of every document is important. Making it virtually viable is very important, and thinking in a virtual contractor way is very important. So coming into the picture in between the design and taking all the services virtually and following the process and highlighting the issues, challenges which is going to be at the later stage and may kill and save lot of times save lot of times in this making the process and the GFC documentation, which we can rectify as soon as possible during the design stage itself. How is that possible? Because input from architect and designer is very much studying the plans, 2D drawings, and identifying the gaps. So this making a very simple process, following the RFIs, making a 3D models, identify the areas where the gaps are, then going into the quantities, assuring the quantities are right, and then preparing a project report and then giving it to the contractors, and then making a successful project. Let's go to the case studies, how it works. I'll give you a simple case study to make it successful in our Indian scenario. Still we are far away from the digital technology of talking about many things, but yes, it is possible, and it in a very easy way it is possible. So any data which comes around need to review as soon as possible and has to raise the RFIs as soon as possible. So mera information sharing is very important. If we are not sharing the information from architecture to structure, structure to MEP, this coordination is not happening at early stage, I am sure later on there will be a lot of problems which client will not accept. So this at very early stage, making a proper RFI system, following the system and tracking of those RFIs, the information sharing is very important. You can do it in a very simple way. You can send a snapshot to each other and you can just highlight what is the issue, just making a snapshot only. You can set it on the WhatsApp, make a turnaround time faster. Then go to the 3D part. Find the RFIs in the 3D also. Find the clashes, finding the challenges, what are the challenges which is coming with respect to MEP, with respect to architecture, facade, everything. You can identify those challenges and you can highlight it. The clashes, the ducting clashes with the ceiling. So these all can be done at very early stage. Following this process, it becomes smooth, healthy, and convenient for everyone to understand and make a clash-free drawings. These are the snapshots you can share with the clients, you can share with the each other, with the consultant architects. What are the challenges? You can highlight those and resolve this at very early stage. Then going to the 3D models. I have considered only one floor just to explain how the process is. I'm not going to talk about the tall buildings. First, basics, we need to correct that basics. We need to follow that basics, and then we can talk about lot many things which are required. So this is the space where the interior is also involved and making all the services clash-free by the help of coordination, communication with every stakeholders. So once that is done at very early stage, your clash-free drawings is always there. Your 3D model is clash-free. Your 2D drawing, extracted drawing is clash-free. Your all the services with furniture layout, with machineries, everything becomes a clash-free model. So this is with respect to interiors, with respect to structures, coordinations, and then at that time when you see the clashes on 3D, then you will have a 0 clashes or maybe 1 or 2 clashes. What generally people do, I'm talking about the BIM consultants, and they start doing the modeling and then they say 100,000 clashes are there, how to resolve? Then that also become a lengthy process. So process is very important, following the process and making it successful is another thing. So all the services, how it will be, how it will look like, and then it should be, it has to be. So these are some of the clash-free models which is made for MEP services with respect to structure and architecture. So from the basics, from the structures to making a columns, identifying that, and then coming with the beams, and then coming with the walls, exterior walls, partitions, all of those, and then these services will come in picture along with the furnitures, and your fire will come, then your electrical systems, how it will be, your HVAC systems, your plumbing systems. So making all of those clash-free into 3D, and then going to the visualization stage at early design stage itself. So not only making a virtual model, but also making it feel like virtual model. So you can, so we are doing the virtual reality also. You can make it happen. We are putting a QR code on the drawing itself for a convenient. You can use the VR glass and you can visualize also. You can, before building the project, you can visualize the project. You can identify the corrections. You can understand it from the client. You can take the approval from the client, and then you go ahead for the final GFCs. So if you see, we can visualize the project. We can actually, it is going to help on the site. Also, we are putting on the site, this VR glass we are putting on the site itself. It's a simple VR glass. You are just putting your phone inside the VR glass and you can visualize it. Then going to the sign off of the GFC. Along with that, what is important when you are following the virtual design is your scheduling. So let's say these are very small, I think it's written over there. So we can define the process of the construction also, schedule the process. So in this case, how the construction is happening, in what week, what activity is going to happen, we are going to visualize that along with the Excel sheet which is going to be produced by this, and you can account the responsible person over there and you can tell them, boss, this has not happened, this has been scheduled in the week of third, week of fourth, this was scheduled, but it has not happened, what is the issue? So this is the process which we need to follow at the design stage itself. So this is the purple which is changing, the purple color is what the construction is happening, what the execution is happening. The rest is already done. So this way you can just visualize the entire project from finding the clashes from initial stage to identifying and visualizing the project, and then actually taking it to the schedule level and making it a proper weekly schedule. what happened at the stage of the construction, how it is going to help. You can put the QR codes on the drawing itself. आप ये QR डालो and QR scan करो on your phone and you can visualize. You can have a 360 of that area. So every area you can put the QR code. No need of taking the laptop, no need of taking the hard copies. Throw away. Phone लेके जाओ, scan करो और visualize it. You can visualize all the services. You can visualize your HVAC, you can visualize your MEP services, you can visualize your finishes. Whatever the finishes has been defined, you can visualize that. Even you can put on the column itself. You can put the QR on the column, and this is actually we have done on the site and executed. The project which is going to be on 3 years' time has to be completed in 2 years' time, 2.5 years. So you can put the access, password, whomever you want to give that password, you can give that password to that, and you can have the visualization of the project. This is industrial project I am talking about, and in the tall building only. But yes, it's all possible. During the construction, you can set up the guideline, you can set up the... So tomorrow contractor cannot say a single word कि boss मेरे पास drawing नहीं था या फिर I didn't saw that. Every column has a QR code. You have a drawing with the QR codes. You have a sections on the site. You can have a visualization over there also on the site itself. Lot of the challenges which happen in the plumbing services in residential building, all the tall buildings, you can put the QR code on the bathroom itself, and you can have that 360 panorama of the bathroom with the fittings detail, what type of fitting will come, what type of ducting will come, what is the geyser, what type of geyser will come, how your bathroom fittings will look like. It's easy for contractor also, it's easy for execution also. With finishes, you can put with finishes. Sorry. Sorry. So I think that's not happening. So conduiting, the flats. So this is one of the example. You can put the QR code on the conduiting itself. You can have the 360 of that also. So all the conduiting, if you see, you can see it, visualize it. Lot of the time this, along with that there is an Excel sheet which will give the photographs of every items along with the quantities. And you can update to the client also, you can update to the architect, you can update to the PMCs, what is happening on the site. So actual, what is design versus what is happening on the site, you can show it by just putting the video itself. So this all, when we see the final result, if the process is fine, if the things are good, your final result, your clashes, everything is resolved, and the documentation and everything is fine, your end result will also come in a actual way with the accuracy of above 90%. This is the final interior layouts which we have got from the model and the actual execution. So we take up as a MEP consultant, we take up as a complete virtual design also, and this is what the final virtual model is. If you see, so you can set up the tone from initial design stage to construction stage to the final handing over stage. Now, when we talk about the final stage, you can have this VR QR code drawings, you can have a asset management list, which we are talking about the COBE, you can have a complete IoT based system which will talk itself, and all should be documented on the virtual model. So this is beyond BIM which we are talking about. initial stage to the final stage, we are following the process. We are dealing with that. Thank you very much.
Thank you so much, sir. Sir, could you wait a minute? May I invite Dr. N.S. Ghadge, sir, to please facilitate Mr. Mubashir. Thank you so much, sir. Ladies and gentlemen, we have now reached the lunch break. Lunch will be served at the designated dining area. We request everyone to kindly join back for the post.
Sejal class. It's Sejal class or Sapphire class? Sapphire class. Yeah. So welcome back everyone. So we'll, before we start with our next technical session, that is panel discussion, since everybody is gathering, we'll have a quick video of our sponsor, Sapphire Glass. Sapphire Glass. Video play karo. Connect. You want to connect on? Yeah, unfortunately what has happened, we are now shuffling. So at least your thing will be covered. You want to speak?
Yeah, as a presentation, right?
Then who's going to show the video?
That's what I'm saying, there are two companies. Caesar is also there. I think it is them that is...
So their video will play. You said, I'll call you after call. You are comfortable now or how do you want to do? Let the panel discussion happen.
Yeah, right. You have already given my presentation and again my presentation.
काय करतोय आपण व्हिडिओ दाखवतोय व्हिडिओ दाखवतोय आपण प्ले करा व्हिडिओ प्ले करा सोडून द्या So I'll begin. Welcome back everyone. So we now begin our post-technical session with an important panel discussion, tall buildings, tough challenges. The development of tall structures involve complex engineering, planning, statutory compliance, sustainability consideration, and execution challenges. Today's distinguished panel will share their valuable experience and professional insights on addressing these critical aspects. May I invite our moderator, Professor Sucheta Matthew, former principal, to conduct the session. Ma'am, kindly come on the stage. Yes. Allow me to introduce our esteemed panelists. Our first panelist, Dr. H.M. Raje, a renowned structural engineer, having practiced for more than 30 years in the structural engineering field, having done many tall structures. Dr. Raje, kindly come on the stage, dais. Followed by Dr. Priya Mendiratta, ma'am. She is a distinguished and very experienced planner. Dr. Ajit Satardekar, sir. He is not there. Dr. Navnath Gadge, sir, who brings a lot of experience in terms of approval, as he is a ex-chief engineer from MCGM. Professor Dr. Dilip Sarode, who is an academician. May I request you, ma'am, to please begin the session. May I request Mr. Purushottam Doifode, please. No, earlier the name was not given.
Good afternoon, everyone. This is the afternoon session, and it is a very difficult time to conduct a panel discussion, but I hope you will have a good section because we have an esteemed panel with a diverse experience, and all of them are excelling in their profession and with a great academic background. So I invite all of you for this panel discussion, tall buildings and tough challenges. So we have if you take the tall buildings, we have panel members from each stages of work. We have planning Priya ma'am, Dr. Priya, Dr. Navnath sir, and then we have structural background, Dr. Raje, and then we have Dilip sir, academician, and then we have Mr. Purushottam. So let's we'll start the discussion. So my first question is to Priya ma'am and Navnath sir, because tall buildings are it's a vertical city itself. So it gives lot of pressure on the ground with normal services and the transportation network. So as at administration level, how how we can plan according with the developers before it gives a challenge in the ground level, like it affects the services and before it chokes the services.
Good afternoon, everyone. As regards the high-rise buildings, the first and the foremost is the access. In planning, we start with the access and what is the minimum width of the access required as per the height of the building was to be ascertained first. and then as per the width, say for 180 meter and above, 18 meter minimum width of the access is required. And then according to that, FSR or the FAR norms permissible as per the DCPR and then concerned regulations, one has to plan the building. There amenities, then your services, available services, drainage services, all these requirements and the remarks are to be considered. And then whether there is a requirement of the upgradation of these municipal services, that is also to be ascertained. Otherwise, what will happen? As you go up, the tenements, number of tenements will increase, the peoples living in that building will increase, and of course, requirements of the water as well as the sewage and the network requirements will be different. That also we have to plan. In the morning session also, that you have seen that the traffic maneuvering management, that also has to be considered. Parking requirement within the building, the type of the parking system, because you have to plan within the whatever is the plot boundaries. Then firefighting requirements, all these aspects has to be considered while approving such plans for the high-rise buildings. At the same time, foundations requirements, soil strata, this has to be ascertained, and then the structural engineer will design according to that soil strata for the building. Thank you.
Good afternoon, everybody. I wish to make this post-lunch session little more interesting. I have been with CIDCO for almost 33 years, for more than 33 years, and was part of urban planning's division, and we would understand that urban planning is integration of many things. So being as part of government and particularly urban development division, we are also responsible for formulation of the development control and promotion regulations. So for all these services, like until recently, before the unified DCPR came in, were introduced in December 2020, that was just before COVID. The FSI was not as high as it has become now. And of late, or rather I would say post UDCPR, we have seen that a lot of redevelopment has come into practice. Not only in Navi Mumbai, but also in Mumbai. And because the additional FSI or incentivization of redevelopment, so the government has offered a higher FSI and higher FSI to consume. There is no other choice but to go for high-rise development. However, when we talk of high-rise development, we need clearance from Airport Authority of India, and depending on where you are located with respect to the air funnel, those are governing factors of the permissible height of a building. So those are basic beginning points before we even begin to speak of services. So permissible building height, I have also been involved in grant of development permissions. So got an opportunity to interact with so many architects, and we know the kind of issues that come up with them, the kind of difficulties that architects face in consuming that FSI. Then of late, CRZ and high flood lines, and there are so many such things which have become more stringent. Even fire protection regulation floor. So with all that, and you would see that now buildings have that red pipe for fire extinguishing. Those things we have not seen before, but that have come into existence in the last 5 to 10 years. So these are challenges, and ma'am's question pertains to how we provide water and we ensure power requirement, because in near future we are going to see the age of data centers. So the kind of power requirement, and then we also have become more aware of the environmental changes. So those regulations are becoming more and more stringent, and more new regulations are getting introduced. And I would say, ironically, many of them come through the High Court. So those are things that we need to continuously integrate into our development control regulations. And previously we called them as development control regulations. Now we have introduced that they are development control and promotion regulations, because when we go on site for site visit before issuing the occupancy certificate of a building, so we come across many things like I would say the government's objective of introducing higher FSI was also to provide affordable housing. But how affordable does it really get? Because when we speak to developers, they say that पहले प्रोजेक्ट 4 साल में खत्म हो जाता था, लेकिन अभी प्रोजेक्ट 10 साल में चलता है, तो उसका टर्नओवर तो उसका सेम ही रहता है. So it doesn't really make it affordable. And जो crane structures थे to make high-rise building possible, that kind of number of cranes are not available in the market, so they are unable to, those are their practical impediments to starting their construction, because they book today and they will get the crane only after 2 or 3 months. And Mumbai, we know that losing 3 months in a year is kind of critical, because then you are, with respect to monsoon, you have to schedule your entire project. And otherwise you go dysfunctional for 4 months, when you can do only design part kind of, or only certain part of the building. So those are practical impediments. And for water supply, in our development promotion regulations, we try to incentivize through, like now rainwater harvesting has become critical. And from urban planning point of view, we will see that as more and more surfaces get impervious, then that runoff coefficient itself increases from 0.3 to 0.9. So the flooding itself becomes so much more possible. Like previously, the width of rivers we could maintain, but in an urban area, if we do not provide or monitor the development in that riverbed continuously, then it will become a slum. It will become, all unauthorized development is likely to take place in the riverbed. So those are things that we have to be very, very conscious about. And once unauthorized development takes place, we know that it becomes an entire political scenario, and it is, once there, it is kind of impossible to remove it. Again, we have to get the High Court involved. By that time, the third party interest has been created, even if that building is not registered under RERA. So those kind of difficulties we are continuously facing.
Thank you, ma'am. Form and force. We know that when the buildings go higher, the design of that building is more managed by the law of physics. So how do we deal with it? My question is to Sir, Rajesh Sir. When there is a architectural aesthetic consideration and the structural rigidity, how do you negotiate with an architect? And
good afternoon, everybody. My answer is very crystal clear. It is next to impossible to negotiate with the architect. And the most unfortunate part for a structural engineer is that he has got three swords on his head. One, principally the architect. I'm not against, but the architect. Secondly, the geotechnical engineer. Third, the man who makes holes, mechanical, electrical, plumbing. Because what happens when the structural designing preliminary starts, and if you are going in for deep excavations, it starts from deep excavations. If you are going from deep excavations, your shore piling design has to be very prompt. There are two again variants over there. If there is a water level that is very, very closely existing, the drawdown curve becomes a big problem. And if you try to, because see, as a developer naturally he tries to, because the maximum cost comes on the shore piling only. There are two types of shore piling. One is secant shore piling and one is the normal shore piling. In secant shore piling, again the cost increases because you are going to make this as watertight, so that there is no drawdown. This is principally important because afterwards when metro comes close by, the calculations that they ask from you are so difficult that you know what is the effect of your structure to the metro, what is the effect of metro to the structure, then the geotechnical part of that complete explanation. And the unfortunate part today is that the structural engineer is holding a license. But there is as such no geotechnical license. They are doing the soil testing, they are giving the report and they are putting their hands up. With the comparison in the market, what happens, they try to do the most economical design, and what anything happens at the site for the deep excavations, failure takes place, the first person to go behind the bar is structural engineer. This is a big tragedy. So therefore you are my first answer, with nothing to hurt anybody, but then it becomes a really act of balancing for a structural engineer. Why? Because your codes are also going on changing. A code comes in 2009, then it comes in 2016, and then comes in 2025. Fortunately enough, the 2025 code has not been operated. But let me tell you that the codes that we designed previously, my example is very close by, that is Gigaplex, that has been completely over there. A typical structure that was designed which had a consumption of 5.5 kilo in the older codes, when it came to the new code, the consumption shoot to 8.5 kg per square foot. Why? That you required shear walls, you required this, you required that, your torsional motion, this motion, and all these motions comes into picture. So a structural engineer is under fire, first under fire. Why? Because if he has designed this building and now this building, if its consumption is coming up to be 7.5 or 8, the first question that is asked by the owner is that, तुम किसी छोटे बच्चे के पास से डिजाइन करके लिया क्या? Then it goes for peer review. If it goes for peer review, the other fight starts with the structural engineer. There are two types of peer reviewers. Either they manage and they say, "Arey, बहुत skill डाला है इसने," without understanding the implication of the actual problem that will occur at the site. Especially when the structures are given on rent to the international authorities or international bodies, they do the peer review themselves. And they see to it that every single code has been properly. That is the time the owner comes back. Arey lafda ho gaya, abhi strengthening karke do. So these are the 2 points that a structural engineer has to face. The worst point that is there in the engineering today is that when you are going to construct structures in Bombay area, maybe I don't know about Navi Mumbai right now because I have not had that much complications. But in Bombay, the area is very small, number one. Secondly, if it is a tall structure, it becomes a slender structure. If it becomes a slender structure, it is like a coconut tree, which is again principally having deflection in the wind analysis. To control that, there are a number of systems that are available. But if you try to go with the systems, the owner again comes back, "Arey yaar, mera kharcha to parvadega nahi," because outriggers have to be designed. Outriggers are a system in which again there will be problems. So these are complications for a structural engineer. Life of a structural engineer is not that easy. The second unfortunate part is that, suppose if you are able to clear that hurdle. Now let me tell you another example of mines. If you go towards IIT Powai and get down from there, there is a structure that is standing on 4 columns, which has got a span of 50 meters. Principal 4 columns are there, 50 meter span is there, and next 22 floors are floating. Now tell me, as per the new code, will you allow me? No. But luckily that time architect who was really thinking about it had designed those 4 columns to take the aerodynamic forces. So those columns were strongly designed for earth as well as wind. Now questions come for the girder beam. The girder beam which is there for 50 meter span is 2.5 meter by 5 meter deep and cannot be pre-stressed. Why it cannot be pre-stressed? Because in pre-stressing, if you go for the maximum compression that is there, as the number of floors goes on airing, the compression level increases. So if you try to compress if you try to pull the anchors right at the very beginning, it is not possible. So you will have to keep the compression system ready over there, and stage by stage you will have to stress it. So that is ruled out. So if you go for a RCC or composite structure, you require classified contractors to work for that. Do you have that? Now you are developing. Now L&T is developed composite structures. But then what happens? For this particular girder, the question arises. All these designs are okay, but will they really stand? So that was the question of the owner as well as our own question in our mind. So naturally they said, what can be best done? So the best that was done was analog system of checking the particular beam. So what we did is that we put the strain gauges inside, and today also we can monitor the deflection, the bending, the shear. Apart from that, also some gauges are there to observe what is the rate of corrosion that is taking place. But that is analog system that we had designed. Analog system, what actually happens is that you will have to have all your machinery over there, then tap the system and then try to get the readings. We did this. So we really realized that as you went on going on adding the number of floors also, the camber that was given to the beam was roughly about 8 to 9 inches. Believe me or not, as a structural engineer, you will not, that means, in the olden time, people used to say, building ko color mat karo 2-3 baras. Why? Because the structure acts on its own, deforms itself, and in that deformation, some cracks are developed. Now here what happened is that when the loading started, maybe when we went to 12th or 14th floor, we found that all the walls were cracking. So once again it was a question of safety. Arey baap re, ye kya lafda ho gaya? So, but when we reanalyze that and when we check the loading, because the theoretical calculation, the actual real readings that we were getting from there, simple mechanics, that means those who are engineers will realize that we in the strength of materials, we studied something called as Bernoulli's equation, Euler-Bernoulli's equation, M by I equal to F by I equal to that simple equation we had utilized. I come with a teaching background also, and we had that strain gauges and we worked out the deformation, bending and shear. Control systems are there. Today what I am observing is that another important thing, that when the high-rise structures are constructed, do you really are able to maintain the quality? Top floors, is a real single engineer going over there? That means you are depending upon somebody. So if you are depending upon somebody, real-time measurement has to be done. Right now with IIT, we are already analyzing certain, that means the gauges right from the footing as well as in the retaining wall, and you can get your readings on your mobile. So that also we are doing research, so that what happens tomorrow if the building is constructed and if it comes for maintenance, how will you maintain it? What is the problem to the structure? If you are not able to realize that, it will be difficult for a designer to tell afterwards, because suppose if I design today, after 20 years, who knows? The person who is going to see after 20 years should really have the data in his hand, so he can take a call. Because we have been repairing structures of what maximum ground plus 5 floors, 7 floors, 10 floors. But these are now 40 floors, 50 floors, 60 floors. And mind you, maintenance, where we call our society as a cooperative society, it is difficult to get your maintenance. And if it is restoration afterwards, what will be the state of affairs? So this is another sword that is hanging on our head, that how will you try to control these things? And all these things gathered together, this is my actual experience, that what actually happens to the structure. Now again what happens in Bombay, what happens? The architect also is into a problematic situation. When he is designing a structure, he has to adjust the parking. When he adjusts the parking at the lower levels, there are certain columns that come under floating but which are at the edge. Once again, if the columns are at the edge, the torsional motion people come into action. Ye chalega nahi. So imagine what is the problem of structural engineer. It is not just architect also, because architect has got nothing in his hand that time. He says, no, parking to karna hi padega. And to have that parking and to have that turnaround for that particular parking, you have to go for a floating system. And if you have to go for a floating system, your girders which are there, you really have to see to it that real-time measurements are done for that girder to understand whatever is your design and what is really happening. So as a structural engineer, I have to be careful of three persons. Geotechnical engineer, if he makes a blunder, I am behind the bar. In architectural part of it, if I don't listen to him and I request him, sir, ye thoda problem hai, my job is gone. And third is that in the MEP, when the building is constructed and they start making holes, it is including Shah Rukh Khan. Because when I constructed his structure, he says, na mangta hai mere ko hole. Are hole mangta hai, theek hai yaar, beam tum, which is that zone? Is it a shear zone? Is it a deflection zone? So, you know, life of a structural engineer, you gave me the opportunity to tell that it is not that easy. And with the comparison of the young generation entering inside using softwares, it is thrash in, thrash out. So that is another big problem. That means because what happens in the olden time, we had something like, you know, that you can easily find out the nerve. What is the actual happening to the structure, the theoretical calculation, the akade that we had done over there, even for the bridges. I don't find anything right now. It's come, if I have taken to design a bridge for about maybe 3 to 4 months, today they are designing in 3-4 days. So just imagine the speed that we are going. How do we control everything properly? And to control for a structure to be actually existing at the site, architect does a beautiful thing, interiors also he does beautiful, people appreciate that. Nobody appreciates structural engineer. And the tragic situation is that the structural engineer is replaced the time the developer is told by the peer review, ye consumption zyada dala hai, out. So as a structural engineer, as you have rightly pointed out, and he has also departed, it starts with geotechnical engineering. And I would like to talk about, madam, also that cranes and all these things, you know, even if the feasibility of crane is there, sometimes what happens, you know, the location is such that you are not able to manage the span, the movement of the span. If you are not able to manage, because there are already high-rise structures. You know, sometime back there was shadow analysis, this analysis, that is all gone now. Because basically when you have two close high-rise structures, you know what happens, there are so much shadows that are coming, you don't get sunlight. So your deficiency of vitamin D also is there. So these are all the problems. As a structural engineer, when we used to design, we used to find out, glass cladding, heat temperature, cracking of the glass, because you know if the temperature difference is too large also, sometimes the cracking takes place, especially in the pergola areas. So these are our difficulties, but definitely architect who comes with a beautiful artist, and a job is of a structural engineer is to really tailor make that structure the way he wants it. But the downside for a structural engineer who has to accept it right from the beginning, he will never be appreciated. So I think so I made my points clear.
Just a minute. To add 1 or 2 points, in Mumbai, where slender buildings are constructed, and at the top floor swimming tank. That is like a stick, long stick with a lump mass at the end. You know, this has become fashion. In fact, the water bodies in tall buildings should be on ground floor. See, IIT Bombay, the building which is having water body at the ground floor is always cool. So I think that we should avoid, as a structural engineer or as an architect, in tall buildings, no doubt you get privacy on the top floor for swimming, but at what cost? Just imagine when the earthquake comes or wind forces such a huge mass at the top of the slender building, it creates a lot of problems.
I would like to, his point is very much appreciable. I was involved in Gujarat earthquake. There was building in Ahmedabad called as Mansi A and Mansi B. Okay, Mansi A was standing tall. Mansi B cracked and fell down. What was the problem? In Mansi B, the owner was staying at the top level and he decided that the complete terrace should be waterproofing. Your swimming pool. And he constructed the swimming pool. People enjoyed in the initial part of it, but that same owner died in that particular structure. So these are my ideal examples of Gujarat earthquake. Another example, geotechnical. In geotechnical, Akshardweep was there. Akshardeep was A, B, C, D wing. What these people did is that they did geotechnical investigation at one place, and the other building which was constructed came down. The ground floor became basement. So what has happened now for me, I have already observed the failures in Gujarat. And the most funniest part of it, which you will be shocked to listen to me. The buildings that were not designed for earthquakes stood stand and tall. Why? Quality control, line level, everything was perfect. The designs that were done with earthquake calculations did fail. Why? Because you do everything, but if your quality control and everything is not maintained properly, you definitely have a failure. And another important today is the grade of concrete. We are going on higher and higher grade. That is also very important, because a structural engineer should also have a proper knowledge of concrete technology. Otherwise, he will be taken for a ride by the RMC plants that are existing in Mumbai. Any case, again with due respect to everybody, not to hurt anybody, because as a structural engineer, I don't want to lose my jobs.
Thank you, sir, and sir, for giving the engineering viewpoint. So now, next question is to academicians. So generally when architects and civil engineers pass out from the college, they get a cultural shock if they get into a high-rise building. So are we prepare them for any such kind of, this syllabus includes this type of project handling or anything in the current syllabus? Dr. Dilip, sir, both of you.
So, thank you, madam. Very relevant question. The thing is, I am on board of studies in 3 premier institutes for revising the syllabus of the. When we try to introduce modern subjects, the departmental people say we don't have faculty to teach them. Okay? And another thing is, I organized one site visit with great difficulties to Trump Tower, because Trump Tower, there was an agreement given to Trump management, 15 million hours accident-free execution. So they have never allowed anybody to visit. But when I took some government engineering colleges teachers, all the departments, because HVAC is there, mechanical is there, civil is there, metallurgy and all, every department 3 to 4 top faculties. When I took them to 72nd floor, instead of seeing technical things, they done video call at their home. And I was more worried because it was under construction, many ducts were open and things, and such a huge wind pressure. So I think very first thing is we have to train the teachers in the engineering institutes, to be very frank, because most of the engineering institutions are not having experienced teacher, and they expect students to do lot many things which is beyond their imagination. This is one thing. But in spite of that, being from a top-notch institute where industry-institute interaction is the best in India, I have brought some materials which I think all of you should think. These three sections I am able to hold with one hand. Can you imagine? This is I section. This is, and this is box section. So you can think of using these sections. I will tell you, the cable trays, everybody, previous speaker has said so many electrical, HVAC, plumbing, firefighting, so many additional loads are coming because of so many things. So why not to use this material for cable trays? Corrosion free, okay, very light. You can see the thickness, okay. This is fiber reinforced polymer composite, okay. Now most of the tall buildings are having first 5 to 6 floor parking. Many times the car driver who is having learner license try to take turn and dash the columns many times, okay. So at least till the parking floor, for casting of column, use such box girders. And keep them as it is as a sacrificial formwork. Are you able to understand? There is no leakage, absolutely fine with the column. And nowadays, angle sections, channel sections, eye sections are available. Very good strength and negligible weight as compared to steel sections. You change the fiber from this glass fiber to carbon fiber, strength is much higher than steel girders of similar dimensions. These are engineered materials and need to introduce at wherever is possible. In developed countries, because of the change in the loading on the highways, many old bridges, superstructure is removed and replaced with this FRP material. So the dead load is reduced and equivalent live load they have increased on the highways. So wherever is possible, technology is new, but being from such an institute, in near future, at least for high-rise building, below foundation, use stainless steel reinforcement or fiber reinforced. Fiber rods are likely to come very soon, and some places they are used. You can use them at least in the subsoil region. Now, most of the buildings are with Maiwan formwork or tunnel formwork. Entire flat, all three sides are with concrete. Just imagine when the temperature is above 40, what must be happening inside. Okay? So there is a need for heat reflective coatings on the outer face. We must encourage the use of material which is having less heat of conductivity. In Brazil and Russia, I work with some of the scientists. They have very good phosphogypsum and gypsum partition walls. Even in developed countries, many places partition walls. So why not in high-rise building, external wall you can have, but internal wall you can have with gypsum board or gypsum. So such an antifungal coatings are likely to come in near future. So sometimes bacteria can work as a strengthening of the structure. Myself did PhD from IIT Bombay in bacterial concrete. So there is possible. Only thing, a lot of research need to go. Now you will be shocked to know, in India we are manufacturing 1.5 to 2 meter diameter pipe made up of polymer, which is used for wastewater and industrial effluent so that no corrosion. Which is having 3 centimeter shell thickness. First time used in Chennai sewage disposal marine outfall. So try to use these advanced materials and improve the applicability of to the industry of the latest material. No doubt these sections are just representative, and many companies have come forward now, they are manufacturing. There are some issues, but unless you use and increase this usage, those difficulties cannot be overcome, because industry feedback should be given to these manufacturers to overcome those difficulties. Thank you.
Good afternoon to all of you. I initially, first of all, extend my sincere thanks to Sri Suresh Babuji. Because of him, today I am here. Actually, I am little away from all of you. Why? Because I am part and parcel of the Ministry of Defence and Government of India, and I am UPSC 97 batch officer, and I am presently director in College of Military Engineering. By virtue now I am posted as if like a professor, ma'am, but otherwise I am architect, town planner as well as civil engineer, 3 in 1. You might have seen 2 in 1 in architecture and planner, but I am 3 in 1. So first, what ma'am's question was with related to academics, I will tell first that point. Thereafter, one experience which I had in Chennai. I will spell about that also. So I will not take more than 3 to 5 minutes, if you allow me. And the first example which I would like to quote is when I was serving in headquarters Chief Engineer Bhatinda zone. Most of us, you might not be knowing, कि we always think कि there is only one area which is covering the border of the LOC, but where I have served, I had much more area of the border, which is consisting of Punjab as well as Rajasthan. So when I was serving as a officiating director there for architecture, I was nominated as board of members for new development of Central University of Punjab. So by my good deed there and by my good suggestions, somebody recommended me for being the board member for the Board of Studies for Civil Engineering in DB University at Mandi Govindgarh in Punjab. So there, Sri Ravi Shankar also, sir, is, Ms. Guruji is also associated with that institution. So when I visited the university, there was long 2-3 hours of discussions. Ki we will do such and such things in civil engineering. We will introduce this much theory. This much is remaining. Students are not having this much. Then after listening everybody, I only asked few basic questions. Ki whether the civil engineering pursuing students, how much of sessional work they are given. So you will be surprised to know, ma'am, it was only 5%. Just 5% of practical knowledge was given in that institution. When I asked, ki please let me know how many civil engineers are knowing what is the differences in bridge construction, water tanks, railway tracks, then culverts or dams, and so many things which civil engineer has to understand. So have you any point of time given such an live example? Then nobody was answerable. This is again the point to convey with respect to academics. Then when I told in my architecture and town planning sessional, I have done 50%. And that's the reason any client I can handle in any way. But as a civil engineer, it becomes difficult. So after a lot of discussions, to your surprise, the institution has agreed for 30% sessional works from 5 to 25. So that is one of the special achievement, and I feel pride for being the nominated member, and the institute has taken care of this respect. So this is one of the example. The second example which I would wish to quote, when I was serving in headquarters Chief Engineer Chennai zone, so I was responsible for all 4 states of South, Andhra, Tamil Nadu, Karnataka, Kerala and Puducherry area. But there, Puducherry, there is no defense much establishment. It is Karaikal. You might have heard about Karaikal, where that atomic station is there. So near to that Navy is there. So when I was serving in Chennai, there was one project which was linked with Army Welfare Housing Organization. It was 33-storied constructions. It was of having the buildings which were of 6 towers. 6 towers were planned and constructed with, again, the My1 technology, as sir was spelling, that with respect to aluminum formwork. But let me tell you, sir, I have seen on ground my colleague officer, the colonel officer who was the project in charge there, we have seen ki literally the cement which was of not badge number or which was having the expiry date were returned to the company. The quality care has been taken very much, and that has been wonderful, successful project I have seen from my eyes, which is still standing. If you just happen to go to Old Madras Road in Chennai, this Army Welfare Housing Organization's project of 33-story, which I was also knowing, this is one of the case which is one of the eye-opener. And let me tell you, since that area was of marshy land, the structural care was taken there also, but the heat island effect is not coming that area, because the sea is also near to that, means say for example 4 or 5 kilometers from that area, and due to marshiness the care was taken, anti-corrosive treatment also is taken. So now the third aspect what I wish to discuss is that irrespective of planning, irrespective of any technology, whatever you go, quality matters much, site visits matter much. Whatever you are, whoever you are, you have to be on ground personality in any case when you are a professional personality. You should not be confined only to the computers or the softwares as such. That I have learned on ground, being 3-in-1 in the profession, and this was one of the live examples I have quoted. If the time permits, I have completed my 5 minutes, ma'am. If the time permits, I will discuss some other example also, if the other speakers completes. Thank you.
Thank you, sir. Next question to Priya, ma'am. We talk about sustainability. When we go for high-rise building, are we creating wind tunnel effect and maybe increase the urban heat island? Ma'am, what is your, are we using this GIS and all this in mapping the urban heat island in CIDCO?
So far we are not, it has not been used, but I think that it is a very relevant topic that needs to be introduced, because as I said that until December 2020 that FSI issue was not, and further to that 2 years we lost in COVID. So now that we are seeing such a big amount of high rises, this becomes very, very pertinent, and that we need to more and more deliberation on it, because now with real-time data, simulation has become possible because of good computing abilities, and this is time that we use all this and incorporate into our considerations, because otherwise as we are increasingly becoming environment conscious, we realize that this kind of things will cost us much more in the future if they are not addressed at the right time.
So this is the right time we have to think about our...
The right time is gone, but high
yeah,
time.
at least, yeah,
I would say high time that we looked into it.
Thank you, ma'am. Sir, when we go high-rise building, like the flexibility is gone, right? Yeah, to right, sir. So interior spaces and all that, the flexibility, do you feel flexibility is little less when we go high-rise buildings because of the structural elements?
No, this only happens in the lower areas. See, usually what happens in the high-rise, when you sit with the architect, already the planning is done over the size of the columns. Only problem is that if he starts further smashing the size of the columns to have that interiors, then it is a problem. But especially if the architect has planned it properly, I don't find any difficulty in your area utilization for interiors. Absolutely not.
Actually, this is about, if you talk about the urban poor, sir, what is your opinion about this urban poor shifting into high-rise buildings? Is it advisable, or will they have to deal with the services and all that issues?
Normally in a Bombay area, the shifting of posts, as you said, because most of the buildings are redeveloped buildings. So there are existing chawls, tenants, then the buildings are getting redeveloped. Ultimately that buildings goes high rise. Initially the height 32 meter above is a high rise as per our UDCPR 2034. Then the requirement of different heights are there. Initially 70 meter and above was to be referred to the high power committee, high rise committee, sorry. Then it was 120 meter and above. Now it is above 180 meters. Now in the DCPR itself there is a specific provision to take care of these tenants shifting into these buildings, redeveloped buildings. That corpus fund or something like that, is that a permanent arrangement has to be made to take care of what will be the enhancement in their assessment taxes and the additional liabilities coming on them. Now, in the redevelopment and considering the sentiments of the people, the government has enhanced the FSI, as rightly said by the madam, because that in FSI, enhanced FSI, is to be consumed in situ, because people are reluctant to shift to the other places. So ultimately, more and more tenements will be constructed on the same plot. Parking requirement again, parking requirement either in the basement or in the upper floor, steel portions, accessible by way of ramp if the plot permits, otherwise by way of lift or a standalone your tower, car parking tower. So different arrangements, different planning aspects are there. Ultimately, this entire redevelopment results into high-rise building, and I think as the peoples are reluctant to shift from there, only the provisions which are there in the DCPR are to take care of their whatever the difficulties coming to them. Thank you.
Thank you, sir. When we talk about high-rise building, the most challenging part is the safety of the people and the material. So, Dilip sir, what is your idea about firefighting in high-rise building? What are the challenges that you?
Yes, this is one of the most important issue, because nowadays temperatures are also increasing, and obviously the fire possibilities is also increasing. I have seen in US, I was in University of Arkansas, where the sections, steel sections were coated with some fireproof coatings. And once the fire occurs, they itself will expand and they will become the resistive barrier, so that the heat will not reach to the steel section. So such stick sections, I know this recently in next 5 to 10 years, there will be lot of development in paint industry and anti-corrosive coatings, because paint industry is changing a lot of new type of coatings are coming, and I think we all should use it judiciously. One of them is fire coating.
Thank you, sir. One last question to all of you. Please, now if future is in AI, so what is your idea, what is you have to talk to younger generation or students, or what you will tell them? In one sentence you can explain.
So before going to AI, like in IT industry, we study from the minute data to major data. So I would recommend entire material and technology, its usage, its planning, everything has to be in totality we must understand in detailing. One example I would quote, in high-rise buildings, I would recommend the railing should be avoided, horizontal railings. there may be possibility of children falling from the top floors. So please use such type of railing where the children, small children can't access and climb up. So vertical railing is recommended for that. Though with this small example, I hope I tried to explain कि minute to major, all detailing aspects are essentially required to be known before going for AI. This is my opinion.
AI applications for having the maintenance and other services after the construction is over is welcome, but society should have annual maintenance contract also. Otherwise, it's very difficult to maintain all this system. And new education policy, national education policy, is creating a lot of confusion. Now, diploma holder in any field can take civil engineering, and civil engineering diploma holder can go in bachelor of mechanical or computer science or IT. So in near future, we will not be having good civil engineers, and whereas the industry is going to need much bigger quantity, good quality engineers.
Again, I would like to say that we need to tread with caution, because there are so many things that need to be incorporated, and with high-rise, the number of considerations that need to be considered while constructing high-rise structures are increasing manifold, because and new technologies, everybody wants that they should be able to control their room temperatures while they are still in the car parking or while they are still at the traffic signal. So all those things, when we are integrating by virtue of AI, we need to be more and more cautious, and as Dr. Sarode said, that we need to look at it very comprehensively. No piecemeal planning would suffice.
Thank you. Sir. Just one. Anything you want to tell about AI to the students? No.
Nothing about AI.
Thank you. Thank you to our respected moderator and panelists for such a meaningful and enriching discussion. The practical experience and expert perspective shared today will definitely benefit all of us. May I request the volunteers to please help with the felicitation. May I request Engineer V.C. Kamble sir to please felicitate our moderator, Suchita ma'am. Sucheta Matthew ma'am. May I request SP Singh sir, our chairman, to felicitate Dr. H.M. Raje. May I request Suresh Babu sir to please felicitate Professor Dr. Dilip Sarode. May I request Pandarkar sir to please felicitate Dr. Navrat Gadge. May I request Dr. Deshmukh, sir? Dr. Deshmukh, sir, please felicitate Mr. Purushottam Doizode. May I request all the panelists and the moderator. May I request Mr. Darak, sir, to please felicitate Priya, madam. Thank you, thank you. May I request the panelists and the moderator to please be seated. We shall now have a brief presentation by one of our sponsor, Sapphire Glass Solutions Private Limited. May I invite the representatives to kindly begin the presentation.
Good afternoon, everyone. Good to be back again after a few hours after lunch. I am Hussain Rampurawala, Director of Sapphire Glass Solutions Private Limited, and I am into safety glass manufacturing and 24 years into the industry now. We have already put 4 tempering factories in Mumbai and Pune. And today I am here to show you my entire factory here itself, because everyone coming to the factory is a little difficult. So yeah, a small vision of our factory where the processing happens, the sneak into the kitchen where your food will be cooked, and the reason why your buildings will look extraordinarily beautiful. So let me take you for a small presentation. There are 2 images in your vision, one at the left, one at the right. Both have a reflection on water. The theme of this presentation is this reflection. Just keep in your mind, in normal scenarios, we will like any of them depending on our moods. But what would you like to see on your building is the question. The tempering industry started on a large scale from 1980s, where toughened glass and increasing the strength of glass to use in larger size panels became a need of the hour. Single chamber furnaces were invented to temper the glass. But as and when time changed, geographical challenges increased, Middle East became a strong player and an important market, where heat was the biggest challenge. And to comfort the people living there in the offices and the residents was the biggest challenge of that time. So dual chamber technology was invented to temper glasses for projects like Burj Khalifa itself. So yeah, we have in India introduced a dual chamber tech, and almost I think so we are the only ones in India to have it in production lines. So let's see how sapphire glass is different from other competition. Here there are a lot of architects and developers also. Very common situation when the rendering is offered to the developer, the reflection of the glass and the aesthetic reflection of another building coming onto your building is shown to be very clean and neat and crisp. All the lines are very straight at the edges, and the reality when the glass is tempered and delivered on ground, the building does not look like this. All the straight lines get converted into slightly wavy angles, something like this. I hope it's very visible, the difference, the pre and the post. This is assumed and this is delivered, and everywhere, because tempered glass, the process of tempering brings distortion as a part of the process. How much you can control is the question. So at Sapphire, what we are doing, I'm taking it ahead from here. The distortion in the glasses, normally when you move around, or if you're in a flyover, just move around when you see buildings on your left and right, you'll be able to see your reflection very wavy and wobbly. These are few examples of our city. The reflection of the building is the reality of the tempered glass. The sky reflection will always be beautiful. The latest buildings coming up these days, the work is not even finished yet, so the distortion is already pretty high. These are buildings in ICAI and BKC, pretty new. Then there are kinds of these pothole effects. These are all processing problems. These are not glass problems. Raw glass is always straight and good, like your mirrors. But the problem is when you process the glass goes through 700 degrees, almost melts, and you have to make it straight again. The art, the precision, the technologies involved to do these things is the most important thing. Now this is sapphire versus competition. Left, both the glasses are tempered by sapphire, processed by sapphire, and right, both the glasses, and the left side is our competition. The entire competition in India, I would say, because everyone is almost using a single chamber furnace. We are the only ones using a dual chamber. So if you see, there is always a framework that changes in the edges lift during tempering, and there are roller waves in between. You can see the aesthetics and the alignment of everything will get destroyed in the left two glasses. There will be 4 frames formed, and those 4 frames will be missing in my processing, that is on the right side. And when you move, this is the difference that we'll see. 100 panels together. I hope the pulled image is very clear, it's very prominent, and it's available in every building available in our cities, pan India. But both the glasses on the right are processed by sapphire. The symmetry is perfect. If you see the sloping roof also, it is actually straight. There is no edge lift. Few examples of our city, the airport is already started to delaminate. This edge lift is the major reason for delamination, and the life of the product gets destroyed. Phoenix Market City Mall, Kurla, our city mall, Ghatkopar, all the malls railings are delaminated. All 4 edges are delaminated. They look milky. Why is that? it is in controlled environment, there is no rain, there is no harsh environment, then also all the glasses are delaminated. This is our international airport. Hardly 4 or 5 years and the glasses have already delaminated. The reason is edge lift. That is already shown in the previous slide with the video. Not just one glass, two glass, all the glasses will start delaminating in the next 1 or 2 years. This will be the beautiful sight of our airport. All this work is not done by Sapphire, I'll be very clear. Recently concluded work at my site, and this is a perfect example to show you the difference. If you look closely, the reflection of the building, although not cleaned yet, but its symmetry is very perfect. Even the small squares that you see around are very clear. Even the small squares and the symmetry of the reflection of the building is very clear, very straight. It is not wobbly, and it makes sure that the building looks beautiful for a lifetime, because these defects cannot be reversed. No matter how expensive glass you bought from the entire world, you buy glass from Saint-Gobain, you buy glass from Guardian, you buy glass from Ashai, the moment you put it in a single chamber furnace, the glass is taken 25 years behind time and it will look that old. And this will not be repaired ever. This is the last question I want to ask all of you all. What kind of reflection do you want on your building? The left one or the right one? The ripple effect is already there in all the buildings. We at Sapphire offer you the left image. As it's very difficult to take each and every person to a factory and to show the scale of productions and the capability and capacities, we've made a small short video of 1.5 minutes. Would love to take you all through that. Send.
Thank you for the informative presentation. May I request, sir, please, and thank you for the valuable support to our seminar. May I request Singh sir to please felicitate him. Now we move to another technical presentation. It is my pleasure to introduce Mr. Gurdas Parwani, a seasoned professional with extensive experience across technology, engineering, business development, and digital solutions, with a professional journey spanning over 33 years in the field of fire safety, security, automation, and construction technologies. Mr. Parwani has held leadership positions with renowned organizations including Honda, Cummins, Zycom, and SmartGuard Solutions. Currently is associated with ventures such as Lafette LED Solutions, VB TerraScan, and Resilient Techno Solutions, where he focuses on advanced technologies including scan-to-BIM solutions, digital twins, BIM consultancy, drone-based project monitoring, thermal scanning, and digital construction solutions. A respected industry speaker and thought leader, Mr. Parwani has delivered sessions at various seminars on AI-based technologies, BIM solutions, and smart construction practices. His articles and technical papers have been published in leading trade journals and magazines. Apart from his professional achievements, he is actively involved in social initiatives through Rotary and educational institutions working towards the upliftment of tribal and rural communities. May I now request Mr. Gurudas Parwani to kindly address the gathering.
HDMI. वीडियो भी है, एक वीडियो है। चलेगा? वायर बड़ा है, लंबा।
आपका प्रेजेंटेशन में ऑडियो है ना?
प्रेजेंटेशन में वीडियो नहीं है, अलग से चलाऊंगा ब्राउजर में। Good afternoon, everyone, and at the outset, I am grateful to IEI organizers, Architect Suresh Babu, our friend, and also all the dignitaries present here that for this opportunity to present technically on this kind of solution and the emerging technologies which are available for. We saw in the morning and the first half, we saw some presentation on BIM, the BIM design and the BIM model. However, there are challenges in penetration of BIM model in generally overall the world, but in India more. Even countries like Japan, their penetration is not more than 40% going on BIM model. But Singapore has advanced very much because they have made it compulsory for every building's plan to be made on BIM model. उसके बगैर उसका plan ही pass नहीं होता है builder का जब तक वो 3D model submit नहीं करता है. So anyway, this is a gamut, and also we are saying we are in the AI-based construction management solution. Through AI, we want to monitor the construction progress and through this technology. How and why, that we'll see differently, but people will think that India में इतना सब आदमी है, AI की क्या जरूरत है? But there is, you are right with this question partially, because the way our vision of country's economy is growing, the infrastructure is growing, and the stable government which is pushing the initiatives and the investments. There was some article by 2030 or 35, India will be third or fourth largest economy in the world, overtaking all others barring China and US. So with this and the $3 trillion, the vision, with this, there will be and there is lack of or dearth of skilled laborers, engineers, and lot of things. The manpower, the way we have to progress, here, and the way we have to move fast, the manpower is not available that, and the skill gap is also there. So AI will help. That's the background with we are focusing on these technologies, AI-based solutions. we have partners, technology partners. This is the list of the solutions. So core and crux is you design the BIM. और राजेश साहब ने भी बोला उनके पैनल डिस्कशन में कि जो अर्थक्वेक के लिए बिल्डिंग डिजाइन हुआ बट वो भी गिर गया, बिकॉज वाई द एग्जीक्यूशन progress, the quality and everything has to be also matching, not just the design part. So we are here in that part. We don't focus on design much, but we are focusing on the execution, the capabilities of execution, monitoring that execution, managing, and also the complete workflow and everything. So which with the automation, this will become super efficient to the extent that we'll see that. But with the scan to BIM, we are creating as-built BIM model. तो जो बना है उसका हम BIM बना रहे हैं, जो डिज़ाइन है वो नहीं है, थियरी नहीं है, थियरी कुछ भी नहीं है इसमें सब जो है आपका बन रहा है, इंफ्रा बन रहा है या बिल्डिंग बन रहा है, whatever is being constructed, उसका we will give you as-built BIM with a 99% accuracy. Because we are using LiDAR technology, LiDAR has a tendency to make error only 20 millimeter in the length of 100 meters. So you can imagine it is more than 99%, but safer side I claim that I can give you 99% accuracy. BIM consulting, okay, we are not focusing here much, it is BIM design, वो इतना हमारा उसमें focus नहीं है, but we provide that. We are also, the more what we have developed is digital project monitoring through LiDAR. इसमें हम क्या क्या देते हैं वो हम थोड़ा डिटेल में जाएंगे, नॉट वेरी मच डिटेल बट वील जस्ट सी द फीचर्स व्हाट ऑल वी आर गिविंग. ड्रोन बेस्ड प्रोजेक्ट मॉनिटरिंग, वी फ्लाई द ड्रोन, उसमें हम स्कैनर रखते हैं ड्रोन में एंड देन वी गेट द कंस्ट्रक्शन प्रोग्रेस मॉनिटरिंग. नाउ दिस इज थ्रू टू टेक्नोलॉजीज, लाइडार के थ्रू भी होता है विच इज वेरी एक्यूरेट एंड गिव्स BIM मॉडल ऑफ द एज बिल्ट, एंड देर इज अनदर टेक्नोलॉजी कॉल्ड फोटोग्रामेट्री और RTK. उसके थ्रू हम we don't get BIM या 3D मॉडल, बट हम उसका कंस्ट्रक्शन प्रोग्रेस मॉनिटरिंग मिलता है, उसका भी थोड़ा डेप्थ में हम देखेंगे एक स्लाइड. देन कम्स द डिजिटल ट्विन सॉल्यूशंस विथ लाइव 360 डिग्री. नाउ वी हैव सुपर एनहांस्ड दिस. व्हाट वी हैव डेवलप्ड इज नॉट जस्ट अ डिजिटल ट्विन, वी फर्स्ट तो उसका फाउंडेशन है एज बिल्ट BIM. बिल्डिंग का हमने एज बिल्ट BIM तो बना लिया, अब उसमें ऊपर एसेट टैगिंग और एसेट ट्रैकिंग डाल दिया. सारे एसेट जो भी हैं उसमें पंप्स, ये AC, व्हाटएवर इलेक्ट्रिकल पैनल्स, व्हाटएवर एसेट्स आर देयर फिक्स्ड, उसका सब टैगिंग हो गया, उसका मेटा डेटा आ गया, उसका ट्रैकिंग आ गया एज वी आर सीइंग, एंड देन उसका लाइव मॉनिटरिंग भी आ जाएगा विथ 360 डिग्री मॉनिटरिंग डिवाइसेस वी हैव डेवलप्ड, यूनिक वन. एंड वी आर टॉकिंग अबाउट सिटी लेवल डिजिटल BIM, डिजिटल ट्विन, नॉट ओनली जस्ट बिल्डिंग, पूरे स्मार्ट सिटी को, पूरे सिटी का हम यहाँ बैठ के अगर नवी मुंबई म्यूनसिपल से साहब हैं, आई थिंक ही इज देयर, और NHAI से हैं सर, तो यहाँ बैठ के यू कैन मॉनिटर ऑन योर कमांड कंट्रोल, ये बिल्डिंग इसका क्या पैरामीटर्स चल रहा है, ये बिल्डिंग इसका क्या पर A, B, C, whatever buildings are there, you know. So like that, it's a city-based monitoring complete. Then we are into thermal scanning solutions, which is part of digital PMC also, but we give standalone also. But we don't do just spot scanning. छोटा spot scan नहीं करते हैं. We scan the complete building or complete floor, जिससे पूरा water का जो seepage leakage का pattern है या एरिया ऑफ इंटरेस्ट है वो हमें मिलता है. वील सी सम स्लाइड, वन स्लाइड, वील स्किप दिस. सो दिस इज अवर ड्रोन बेस्ड लैंड सर्वे, बिगिंस विद द लैंड सर्वे. RTK के साथ हम लैंड सर्वे करते हैं, तो इसमें उसका कंटूर मैपिंग, एलिवेशन, टोपोग्राफी, ऑर्थोमोजाइक, एवरीथिंग इज अवेलेबल. वी डू दिस ड्रोन बेस्ड लैंड सर्वे विथ लाइडार ऑल्सो. तो इसमें वो सब मिलेगा जो पहले मिल रहा था, बट इसमें ट्रीज का डेटा भी मिल सकता है, ट्रीज का गर्थ, कैनोपी, लॉट ऑफ डेटा विथ लाइडार. प्लस वी कैन गेट 3D मॉडल ऑफ द लैंड. देयर इज अ स्मॉल वीडियो बट वील नॉट, may not have much time or it's not playing. Okay, we'll skip the video. Drone based construction monitoring, now this is through RTK और photogrammetry. इसमें 3D मॉडल नहीं मिलता है बट वीडियो मिलता है, 3D डिजिटल ट्विन मिलता है वीडियो वाला, नॉट BIM. एरियल प्रोग्रेस मैप, प्रोग्रेस रिपोर्ट, कुछ इश्यूज है तो 2D ड्राइंग विल बी सुपर इम्पोज्ड ऑन द कंस्ट्रक्शन और उसका जो डिफेक्ट है, डिविएशन है, वो मिल जाएगा. मतलब जो आपका बना हुआ है और जो आपका प्लान था 2D, उसको दोनों को सुपर इम्पोज करके वील गेट द डिविएशंस in the RTK. Now comes the real crux. This is our best thing and this is the technology which now is being implemented, LiDAR based or SLAM based, whatever we call it, digital PMC or digital progress monitoring. In this, we are getting lot of things. This is the scanner you are seeing on the right side. It can be flied on drone also or handheld also, both the options. और इसमें हम दे रहे हैं as built 3D model, as built 2D drawings, and प्रोजेक्ट का अगर बिम डिज़ाइन है, बिम प्लान है, तो उसको भी सुपर इम्पोज करके AI के थ्रू वी विल गेट द डिफेक्ट्स एंड डिविएशन कि वॉट एवर इज गॉन रॉन्ग. अभी रोड का भी अगर हाईवे का भी है, उसका बिम मॉडल रेडी है, तो उसके हिसाब से जो भी आपको ग्रेडिंग है, व्हाट इज द डेविएशन एज बिल्ड में. यहाँ बिल्डिंग के लिए वी गेट ऑल्सो डेविएशन एंड द टॉलरेंस लिमिट कैन बी सेट बाय द क्लाइंट 5, 10, 20 mm जो भी सेट करना है. उसके ऊपर वो आपको रेड दिखाएगा AI और उसके नीचे जो है वो ग्रीन या ब्लू दिखाएगा डिपेंडिंग ऑन द दिस थिंग. ये इस तरीके से एज बिल्ड बिम बन रहा है. आप राइट में देख रहे हैं वीडियो में. इट इज़ क्रिएटेड एज बिल्ड बिम पूरे बिल्डिंग का, और फिर वो बिम एंड बिम प्लान को डिविएशन में हम मॉडल में कन्वर्ट करेंगे. ये अभी डिविएशंस है. Right side is a BIM model plan and the left side is a as-built BIM. In the small video, if you can see on the right bottom, and left side में जो अभी color demarcation आएगा, the red will be which is deviated from the BIM design. BIM design से जो भी deviation है, कहीं पे cutout नहीं था और बन गया है, कहीं पे था और नहीं बना है, whatever, you know, either way, जो भी deviations हैं वो सब मिलेंगे with the tolerance level. एंड इसके साथ हमें वीडियो वॉक थ्रू भी मिलता है. वी गेट वीडियो वॉक थ्रू साइड बाय साइड एंड द एज बिल्ट बिम. देन वी गेट डिफेक्ट्स, वी गेट थर्मल एनालिटिक्स, वी गेट 360 डिग्री वॉक थ्रू, वी गेट BOQ ऑल्सो फॉर द बिल्डिंग्स. कंप्लीट BOQ ऑफ 25 mm एंड अबो ऑब्जेक्ट साइज, एवरीथिंग इज अवेलेबल. यानी पाइप 25 mm के ऊपर के पाइप मिलेंगे, डायमेंशंस. रेस्ट ऑल वील गेट एवरीथिंग, वॉट एवर कॉम्पोनेंट्स आर गोइंग, बारिंग रीइंफोर्समेंट. रीइंफोर्समेंट का नहीं मिलेगा क्योंकि वो विजिबल नहीं होता है स्कैनिंग करते वक्त. दैट आई कांट गिव यू. रेस्ट ऑल मेजरमेंट्स वी विल गिव यू. दिस इज द डैशबोर्ड विच कैन बी कस्टमाइज्ड फॉर द क्लाइंट. दिस इज थर्मल. नाउ इन द वीडियो इफ यू सी राइट साइड में, दिस इज अ पार्किंग और बेसमेंट एरिया ऑफ अ लार्ज IT कॉम्प्लेक्स, IT पार्क इन चेन्नई. नाउ लेफ्ट साइड में देर इज लॉट ऑफ वाटर बॉडीज बीइंग सीन. यू नो, राइट साइड में जो वीडियो है उसमें आपको ना वॉल में फ्लेकीनेस दिख रहा है, ना ही डैम्पनेस है, ना ही पपड़ी निकला है, कुछ भी नहीं है, बट देर इज अ लॉट ऑफ वाटर फ्लोइंग इनटू दैट. सो दैट इज व्हाट वी गिव यू विथ AI. दैट इज अ एरिया ऑफ इंटरेस्ट एंड रिपोर्ट कैन बी जनरेटेड एंड बेस्ड ऑन दैट वंस it can lead to the root cause. I don't say I will give you root cause. I can't, because you know my scanning will give you the area of interest पूरा. वहाँ के इनका भी ये जैसे IT पार्क का था, यहाँ पे जो एरिया ऑफ इंटरेस्ट दिया वो वॉल और स्लैब से पूरा पानी जा रहा था, दिखा हमें. उसके बगल में देर वॉज अ लैंडस्केप एरिया एंड लैंडस्केप पाइप वॉज फटा हुआ था वहाँ पे, इट वॉज ब्रोकन. तो वहाँ से द वाटर वॉज सीपिंग, but it was coming out at somewhere else, but flowing from that area, which we saw in the thermal scanning. AI-driven digital audit. Okay, now we move to digital twins. So as I said, जो अभी ये digital model बन गया building का, तो उसको twin कैसे बनाएंगे? We'll put asset tagging, asset tracking, all the metadata will be fed for all your assets, fixed assets, which have to be managed for the facility and maintenance and complete life cycle of the building. We can go to city level mapping. There is a small video here for city level. I'll just take you through that video. Yeah. So as we saw, that was for the building level. And we have one more use case here for casted bridge segments for elevated roads, particularly for the infra sector. We create the point cloud data through scanning, LiDAR scanning, but we scan the components here, in this case, the male-female bridge segments or right-left bridge segments. और उसका जो shear slot होता है, उसके deviations we find out in this scenario. We have done for few of the projects, which you see 19, 20 mm, and this report is already there. It is giving all the deviations, like here also we can see it's small, but yeah, you can see it there on the large screen. So this will help in reducing rework. Our recent success stories for as this seminar is for high-rise buildings. So Birla Estates, Birla Niara is a high-rise building, which we are already monitoring at Worli. Yeah, done, only 2 minutes. Piramal Realty, 40-story buildings in Mulund, Piramal Revanta, Dharavi, a lot of high-rise buildings we are monitoring. Some of them are scan to BIM, like JNPT Hospital nearby. We have done the complete scan to BIM. We have scanned that hospital around 1 lakh square feet, and we have created a as-built BIM model recently. That's our last month only we have finished that scanning. That's all, I think, from my side. Thank you very much, and thank you IEI and the team for giving us this opportunity.
I request Dr. Nilas Deshmukh to please come forward and felicitate Mr. Gurdas Parwani. निया ड्रेस मध्ये होती बघा. May I request Shri Anurag Sinha sir and Mr. Kundo sir to please come forward, and request SP Singh sir to please. Volunteers, please bring the certificates. In the meanwhile, may I request Uday Kulkarni sir to please keep your presentation ready. Sejal ASAP. Where is she? होने दो. ASAP नहीं है. ASAP सीजर क्लास है. लीना मैडम सीजर क्लास गेले ते फेलिसिटेट करायचं आणि ॲस्पाली आहे ना. We'll have a brief video by one of our sponsors, ASP Media. May I request the representative to please come forward? ASP Media. Put the video up. Play.
Infrastructure is the pivot on which India's growth story stands, and ASAP Info Global Group will help accelerate this, transforming ideas into industry powerhouses. This is ASAP Info Global Group, where information, research and connections meet. With a cumulative print legacy of over 200 years, ASAP brings authoritative voices through Construction World, Indian Cement Review, Equipment India, Smart Manufacturing and Enterprises, Indian Textile Journal, Infrastructure Today, delivering in-depth industry analysis and trends at your fingertips. Our work has received appreciation from the Honorable Prime Minister himself. From stage to screen, our flagship events like India Construction Festival, CW Global Awards, Rasta Expo, Construction World Architect and Builder Awards, Cement Expo, Multi Logistics Expo, and the Metro Rail Conference, among others, bring leaders together.
If you talk about this particular exhibition, it's a fantastic, it's beyond my imagination.
We're looking forward to meeting a lot of decision makers and the key stakeholders.
And it was fortunate to be in the exhibition and we love to come again in the exhibition.
ये अकेला अवार्ड ऐसा है जिसमें हमसे कोई पैसा नहीं मांगता, हमको ये नहीं कहता कि आप अप्लाई करिए, हमको ये नहीं कहता कि आप स्पॉन्सर करिए। तो पटौदी जी और सुमित जी का मैं दिल से आभारी हूँ कि ये इंडस्ट्री में कौन क्या कर रहा है और कौन कैसे ग्रो कर रहा है।
Videos and eye-catching graphics tailored for the construction and infrastructure world, helping brands stand out with digital storytelling that resonates.
I want to thank Aspire for this event this evening, underscoring India's commitment to have genuine, real infrastructure surge ahead in the next 5 years.
Pratap Pododu, who is responsible for conceptualizing this idea.
Thank you for the to please felicitate ASP Media, please. Now we have an important session on vertical transportation by Mr. Uday Kulkarni, Managing Director of Utopia Solution. It is my privilege to introduce Mr. Uday Kulkarni, a respected expert in the field of vertical transportation consultancy. With extensive professional experience in vertical mobility, planning and transportation systems for high-rise developments, Mr. Kulkarni has been actively involved in providing innovative and efficient elevator and escalator solutions for modern buildings. Through his company, he contributed towards optimizing vertical transportation systems that enhance building functionality, user comfort, operational efficiency, and safety in complex residential and commercial developments. His expertise in planning and infrastructure industry. Today, I will be sharing his valuable insights on the topic planning efficient vertical mobility in high-rise architecture. May I request Mr. Kulkarni to please come forward.
What we'll do is we'll just go through the kind of a little bit of an evolution what elevator industry has gone through and how now the high-rise, the whole thing is changing, right? That's what we'll do. Why? Why elevators matter? If you remember, there are a lot of young people in the crowd, but a little older generation, some of the buildings, even 4-storied buildings in Mumbai did not have elevators once upon a time, which was in early 80s and early 90s. Even in China, in early 90s, buildings to the level of 10-storied building never had elevators, but elevators then became a necessity. The necessity means you just got to go from the lower floor landing to the higher floor landing. But today, the whole thing is changing. So basically, that is why we feel elevator matters today in today's industry, especially in buildings and as the buildings are going up. Next slide. Okay. So, first of all, can I have this mic? I can't see the slide. Yeah. So many times what happens is cost of poor planning. What happens if the planning of the building is not done right from day one, right from the drawing stage it is not done. I will just give you a few examples in commercial segment and also in the residential segment. You know, many buildings have come up, people are familiar with Bombay, right? Many buildings have come up, commercial buildings have come up across the railway line of Mumbai city. So many a times when the train comes in, the traffic comes out of the train and goes towards the building. And that is the time we call peak traffic, and we have a problem of people waiting for the elevators to go to their offices. So this is something very, very important. So we have to take care of the excessive waiting time interval by the right planning, by right location. How that planning is done, we'll see as we go up. So this is one example of a commercial location. Another example of commercial location is there are many offices in a building. Same office will have offices on 3, 4, 5 floors and maybe cafeteria either on the first floor or some floor in between. So in between there is a lot of interflow traffic which takes place. Now this interflow traffic really upsets the time schedule of the elevators. People waiting at different levels, the time becomes more than around 30 seconds. Normally ideally around 25 seconds to 30 seconds is considered as a fair enough and acceptable waiting time, but it goes beyond that. So that is the time the proper planning of vertical transportation has to be done at the architectural stage itself. Let me take an example of a residential building. In a residential building, I remember a long time back, way back in 90s, a building came up in South Mumbai. That point of time, it was quite, I think, around 30 plus storied building. They planned an elevator to take a stretcher inside. You know, for sick people, it's always nice to have a stretcher. You can carry someone on a chair or carry by staircase. So stretcher was built in, stretcher elevator was built in, but when the stretcher elevator was built in, the passage in front of the elevator did not have enough time, enough place to maneuver. So this was where something went on the planning right in the beginning itself, but the realization happened at a later date. So there are two examples. So cost of poor planning is very, very important. It has to be taken into consideration right at the initial stage. So early designs, what are the early designs? So you have to look at building type, residential, commercial, mixed use, hospitality requirement. Today a lot of mixed use buildings are coming up, commercial, residential. So you need to take care of that. Access to the people who are using the residential part of it, access to the people who are using the commercial part of it. And commercial becomes even critical when you are actually, during the peak times, office time. That is the time it is very, very important. And while doing that, while planning, the right data has to be made available to the elevator consultant or the elevator manufacturer. Then the population, height, traffic pattern, peak usage timing. These are the early design questions we normally ask when the planning has to be done. Next. The parameters which are considered are basically two, handling capacity and waiting time interval. Handling capacity, as per the NBC standards, 12 to 17% of the population has to be handled within 5 minutes time. People waiting at the lobby, how do you take them to the other floors? And other part is the waiting time, as I mentioned earlier, it should be less than 25 to 30 seconds. Anything above that is considered the average or probably below average. While having said that, today elevator is not just to take you from the ground floor or the top floor or wherever you want to go. It has to be your own experience. So the elevators today, inside the elevators, there are provided screens giving information, they are connected to internet, and the latest technology is elevators today are coming with air conditioning. In the olden times, the hotels used to have the AC in the whole hotel, the lobby air used to go, so it was okay. But today residential and commercial do not provide that. So you need air conditioning at the top, which is a complete different experience, plus a screen which gives you the information, plus it is also an opportunity for the people in the, give the information. Like suppose, let's say you want to put some notice board. Olden days, outside the office you put a notice board. Now you can put that in the elevator itself. So the travel time in the elevator is saved looking at it. So it's like a different experience altogether. Next. Okay, now this is the rated load versus car size capacity. Now this is available in NBC, in BIS standards and all. Little unfortunate part today in our country is every Indian today is still taken as 68 kgs by most of the state governments. So the capacity of the elevator versus the floor area is based on one person is weighing 68 kgs, but today no Indian weighs 68 kgs. So 75 kgs, if you take as an average, if you take as the factor, then the proportion should be taken when you are, this is the design, this is the table which is available in BIS and NBC, but you have to take that factor into consideration. Otherwise, the cars become, too crowded for that particular capacity. So this is something you need to remember. Elevator planning and concern. Now there are two factors which are very important from the local authority point of view. One is a pit and overhead dimensions. Now what is a pit? Where there is a spring buffer which is put in, and overhead, obviously in machine room less it's a machine, or above that there's a machine. Now what does the authority consider? Why do you need a pit and overhead with a certain dimension? So there is something known as a run-by. Now this is for the protection of the elevator mechanics. Let's say you are standing on the car and for whatever reason the car overshoots, there should be enough space for him so the accident does not take place. And below also, if the car comes down, if he's in the pit. So these are the run-bys which have been specified in the NBC, in the BIS, and also in some of the European and American standards. So this is very important, and this depends on the speed of the elevator and also the capacity of the elevator. Next. Elevator grouping. So what happens is, for any kind of a residential or even commercial building, there has to be different elevators kept in. Imagine a local train, there are fast train, slow train, and many times we wait on the bridge to find out which is coming and which is coming fast, and people start running. This is exactly the same thing There you have a elevator thing depending on the building designs. How are the offices located? You have to design the elevator shaft based on the planning of the location of the offices. So this becomes very important. Now why is this grouped in different manner is, this becomes a group of elevators, which means one button controls all the 6 elevators. So nearest elevator comes first. Later on I'm going to talk about what is known as a destination control, which will have a little better idea of what I'm talking about now. Next. Okay, these are the general arrangements. You're coming from the lobby, so it becomes more convenient for the people to move in the elevator. So this is a very, very important architectural data which you should keep in your data bank. So whenever you're planning elevators for a building and your planned offices, take this into consideration when you're locating the elevator shaft or elevator core. Next. This is just an idea how the elevator section and the plan. This is the sectional part. You have the elevator moving here. This is the machine room, and that is the elevator machine room which is there. And this is the machine room on the section. That is the machine room on the plan. Next. Okay. Now this is something very, very interesting. As you go up, what happens is, if you just use any elevator to go up, and if you take an elevator which is stopping at all stations, you're not fair to the people who are having offices on the higher floors. So what is done is, the zoning of elevators done. Let's say 3 elevators. The first elevator will be taking care of the first 10 floors, then next 10 to 20 floors, and then 20 to 30 floors. This is something known as a zoning of the concept. Olden times, or rather in 2000s also, when you used to go to Nariman Point area, this elevator available from 1st to 10th, or next elevator is available from 10th to 20th. That is what was the manual zoning. But later on, today now, the zoning has become digital, which I will explain to you as I come to the other slides. Okay. Now, any building which is 200 meters is subject to sway. In India, I don't think there are many buildings. There are, of course, Minerva Tower is the tallest building today. But there are many buildings which are coming up. But the sway factor depends on also the kind of a weather. Cities like Hong Kong, they have a sway factor. Like Minerva today is designed to take care of all this. Suppose if there is a wind, there is a kind of a cyclone, then what happens is, there are certain protections which are given. The main components which are to be protected are the traveling cable, rope, governor rope guide, and counterweight retainer. These are very, very important, because if they are not protected, then there is a chances of an accident happening. Okay, next. Okay, now this is a lift core planning. So any elevators which are above 2.5 meter per second, you have to imagine the lift complete, whatever shaft is there is like a piston, it's a full elevator is moving like a piston in that shaft. And the air finally just moves out and creates a pressure. Now this air has to be removed from various sides. So there has to be certain crevasses, certain openings which have to be provided at mid-landing, top, to ensure this air goes out. If this is not provided, there can be vibrations, there can be noise levels. So to take care of that, this design, this factor has to be taken into consideration. So just to kind of, yeah, go ahead. Go ahead. Okay, flowing air around the car creates turbulence. That's what I mentioned. Giving a lot of generation to the noise. Air pressure will affect the landing door. Landing doors start vibrating. And these things have to be taken care of by providing cutouts at different levels of the landing. How are they provided? Just to give you some dimensional thing. Go next. So if you see this dimension, there is a cutout which is provided right at the top, bottom, and some places it is provided here. But if there is let us say, a shaft which is separated by just a jali kind of a thing, then these are not so critical. But whenever it is not, this is very, very important. Next. This is just to give you a picture of where the cutouts can be. This is the rear wall. This is the rear wall. And the cutouts are given at the side wall on this side. Okay, piston effect for the fire lift. Now, fire lift normally specifies that the complete shaft has to be closed so that, the smoke and all doesn't get him. So in that case, for high storage building, this becomes a big challenge. Ideally, you have to pressurize the complete shaft to take care of the piston effect. But many times it becomes very costly affair to do it. So that is the time you need to work out with the chief fire officer of whatever city you are in to see if you can provide some kind of piston which will take care of the fire requirements also at the same time of the piston effects also. I'm trying to give you tips of what are the necessary things to be taken into consideration while planning the elevators. Now this is elevator car planning. For a standard residential, now in residential there are two kinds of elevators. One is passenger, other is a freight elevator or a service elevator. Now passenger elevator people today are wanting a little more interior, you know. Around 10-15 years back, people's interiors are only for the inside the house. Now they want good interiors in the elevator. So nice glass, good ceiling, tall ceilings and all. So the passenger elevators can be decorated, and many times today the elevator people are giving good finishes, stainless steel, mirror finishes. But in case of a freight elevator where a lot of luggages are to be carried out, you have to protect by kind of, you know, vandal resistant finishes and all, otherwise your things will get damaged. So the freight elevator can carry a fridge, it can carry a refrigerator, fridge plus furniture and all. So you need to protect that part of it. So the designing of the interiors has to take that into consideration for the residential. Especially luxury high-rise. In luxury high-rise what happens is they want a tall ceiling. So that point of time the ceiling height becomes around 3 meters without a false ceiling, and the door height becomes 2.7 meters high. So you have that ambience of a, you know, tall looks which are there. So these elevator car planning has to be taken into consideration what type of the building it is. Is it A grade commercial, premium residential? Okay, now having said that, I'm going to get into the advanced elevator system. I'll just give you some kind of advanced destination control. What is destination control? Have people heard of destination control here? You heard of it, right? Now in destination control, when it came first time into India, people thought it was good only for commercial because peak time traffic had to be carried on. But today, destination control also gives you security. Otherwise what happens, people are having RFID cards and they're putting separate unit for that, which becomes double cost. So here, destination control which are today available can be available for residential as well as for commercial with just RFID card. I'll give you one example. There was one very tall building come up in central Mumbai. The owner of that building was staying on the top floor. So he had kept one elevator exclusively for himself and the other two elevators for the other people, which was not fair enough. So what was done is, we did a destination control system where the RFID card used to decide, it used to identify him, and the elevator actual thing, like he used to come maybe once a day or something like that, you don't have to keep one elevator reserved. So that solved the problem. So destination control is becoming very popular even in residential buildings today. In commercial buildings though, practically today, most of it are with the destination control, but residential also is becoming popular. Access control lifts. Access control lifts is, I told you, just a card system, right? You just have a card, you can get into it. The first time access control system came up in Lokhandwala, where Adnan Swami had his apartment top. And this elevator was opening straight into his apartment. So he had access control only to that. But later on, I think it didn't work very well because people can enter with you along with that. He cannot stop that. So that was not become very popular. Smart grouping. We showed some drawings there. The grouping of the elevators has to be done in a very smart way depending on what is the planning of the building. So that is why it is necessary to sit with the architecture and the owner also, because he may have a concept of what he wants for the building. So it is necessary how you want to group the elevators, right? So this is known as smart grouping. Energy efficiency. Energy efficiency came into the elevator thing only around 20 years back. They started giving voltage variation, voltage fluctuation was there to take care of that. They provided controllers which are more efficient. And now today you also have elevators, while going down they don't use energy. In fact, that energy can be stored to use it for the common lighting, right? So that's also provided. Yeah, this is the advanced elevating system which are available. Coordination with the elevator consultant. So the concept stage, as I was telling you, please involve the elevator consultant right in the beginning. Elevator manufacturer also can help you, but many times his advice can be biased, right? So it is better now. There are a lot of elevator consultants available in the market. Do that. First part is you need to have your data right. Do the traffic analysis based on the data. Okay, 5 years down the line you say you don't know, but you make some provision, like the traffic is going to increase by around 20%, 15%, some assumptions are taken. And the most important is the cost optimization, because moment you have the elevator, you also need to take into consideration what is the maintenance cost. Today in a building, the elevator maintenance cost percentage-wise are the highest. Okay, next. Okay. This is inside of Mumbai context. Standard today in office buildings, 16 to 20 passengers are used with DCS and zone care, that is top floors and bottom floors. Luxury residential building, there are a lot of private lifts which are coming in, and these private lifts are also coming into the triplex. Small lift, which is a home lift. High speed travel, premium finishes, these are available. Market differentiation, depending on what is that project for. If it is kept in the high end, you have all the range of products which are available in the market today. Next. Some of the safety features which you need to take into consideration and try and make it as compulsory. Automatic rescue device. Automatic rescue device, as per the Chief Fire Officer, today is very compulsory. It is a battery operated thing. If the elevator, the power supply goes off, the elevator comes to the nearest landing. 2 hours fire rating landing doors. This was incorporated after there was a fire in Thana some years back, and 4 firemen lost their life. This has been incorporated. All the manufacturers should give 2 hours fire rated doors. Light curtain door sensor. Olden times, the door used to touch you and go. Today, it's a full length light curtain. So you can just throw a card and the door should open. Overload detection system. Visualization in the car. Many times more people go in, it starts ringing. It doesn't take the extra person. Car emergency light. This is in case of a power going off. It is a battery operated, light comes up. Fireman's service and fireman control. This is a compulsory thing since last many years. What happens here is, it's a fireman switch put in the lobby. If there's a fire, actually you're not supposed to use any elevator during fire. So the fireman comes in, he puts the switch on and takes the control of the elevator, which he uses for rescuing the passengers who are trapped, people who are trapped. 3-way intercom. In case it gets stuck, you have an intercom, you can directly speak. This intercom is connected to some master controller, maybe in the machine room or somewhere in the lobby. And door pressure limit sensor. The door pressure limit sensor I just mentioned, it touches you, goes behind. Today it's not required because most of them are giving full curtain. Closing thought. If stairs define structure, elevators define experience. Today, elevators have become like experience. If you look at the automobile industry, how is it shaped up? Today, all the cars which are available are giving you experience. The same thing is happening in elevators. Maybe elevators may be around 5 years behind. So if stairs defines, elevators define experience. So thank you for joining us on the journey through elevator planning and design. So if there are any questions specifically on elevators, I can answer them.
Thank you, sir.
Yep.
Thank you, sir, for the informative session on vertical. I think it's okay. May I request SP Singh, sir, to please felicitate Mr. Uday Kulkarni. Next we have Mr. Prakash Bajaj. He is a practicing structural engineer and a software developer. He has done his BTech from IIT Bombay in 1974 and completed his Masters from University of Michigan in 1976. His software PlanWin and DraftWin is being used by more than 500 practicing structural engineers. In 50 minutes time, he is going to show how structural detailing, how fast you can do structural detailing, which takes more than a month, which can be done in few hours. We are also using his software, and we have found it very useful. So may I request Bajaj sir to start assembling this. In the meanwhile, before your session starts, we have a quick tea break. We'll finish the tea break and then we can have your session. Everybody is requested to please return in maximum 10 minutes, as after that we'll be having a validity session.
Abhi? Means I'm a practicing structural engineer, and this software is called ETABS, which is used by almost 99% of the structural engineer who are doing the design. Now the biggest problem in this software ETABS is a very powerful, but it doesn't give the details. It doesn't tell you how many bars will be required and what will be estimate. So now, okay, we have developed a software called Graphene. So what this Graphene does, it directly reads the data from ETABS, this one design and answer, and does the detailing. So, okay, within about next 15 minutes, 15, not 50, I'm going to show you how fast these drawings can be done. And I'm going to take a small example in which ground plus 7-story simple building will be able to finish in about 10 minutes with the drawing and the design. So this is going to be live demo. So I'm starting with that. So now this building, hello, yeah, you can hear me? Yeah, so see, now this ETABS thing is done, and okay, it has been analyzed and designed. Now this is our software Graphene. So I'm starting with Graphene. Yeah, this is my software Graphene. So what it does, it reads the data from ETABS and does the complete design drawing. And right now it is doing for footing, column, shear wall, combined shear wall, beam, staircase, and all this. So right now what I'm doing, the shear wall takes the maximum time. So I just click on this, and now it has created a file. So I said just open that file, and I just give this file name. Now just within about few seconds it will be making complete drawing. So now see, actually what is done, it has read the data from ETABS file, and now for every element is preparing this one detailed drawing. So what it does, from area of steel, it works out the best possible bar combination, and you can change. But you know what it does the best possible combination, so you can save a lot of steel. Now once this is done, okay, now I say you make the complete drawing. So I am just preparing and say prepare the complete drawing. So it is asking me for some name. I say II, and I say save. So now what it is doing, it is going to make a complete drawing for about 1000 elements are there, and complete drawing is done. Now if you see what it does, from this ETABS, it find out how many numbers of bar required, how much is the required percentage, how much is the provided percentage. So your complete drawing, now only thing what you have to do is just change your nameplate. So that's done. Now see, if you ask any draftsman, just for preparing this one thing, he is going to take at least 10 minutes. So now you just imagine that 1, 2, 3, 4, 8 A1 drawing shows has been done in less than about 30 seconds. And this is part 1. Similarly, if the drawings is large, it is preparing part 2, then part 3. Okay, so almost 1000 elements are drawn in less than 1 minute. Now the next thing I want to work out how much is the quantity. So I just go here, prepare the quantity, and it will, and I say I give some name for this spreadsheet, and it will work out the complete quantity diameter wise, floor wise. So when the building is being done, okay, a builder or contractor would know how much he is going to spend, how much is done. So now I'm just going to show you the spreadsheet. So what it has done, it has worked out for each floor how much steel is required, how much this is there. So when he's placing the order for first floor, he is not going to place, he is going to order only what is required to make first floor, right? Now same thing, now if I go here and I say beam, Okay, I click on beam and I say file, open it, and then it is prepared a complete beam drawing, and now you can see it. For every beam, it has taken number of bars, how much cut length. Now I tell you from my own experience, like usually for building of this type, preparing drawing would have taken at least 5 to 6 weeks. Okay, this is done in less than 4 hours. Okay, now we have also one more software, Planwin. So whether you are engineer or not, if you just understand basic, what is slab, beam and column, so I'm going to show you how we can finish ground plus 7-story building in less than about 10 minutes, including the drawing and the estimation. Now see, the time allotted for me is only 10 minutes. So I'm taking a simple structure, ground plus 7-story, and I'll tell you how it is done. So I just go to file, say new, and for the building you just give a size. How much is the size of the building? Suppose I'm saying 10 by 15 meter, floor height, this is. So now in structure engineer, we draw slab by slab, room by room. So this is, okay, my dimension. Suppose if I change 4 meter, so immediately dimensions are changed. And these are the standard loading. So I said, okay. So my first room is done. For next room, I just go here and just move like this. So my second room is done. Now here I go here and suppose here my room size is 3 meter. So third is done, and then there is a automatic. So I say this, and the slab is done. Now once this is done, now suppose the same thing is okay, repeating. So I said slab data, select all, copy and paste. So this is done. And in AutoCAD and all that, you have to go to exact location. Here I can just place here and it find out the nearest point. So my plan is done, and suppose I'm storing is file save as, okay, I'm just creating some file, say T or whatever, you know, save. Now once my room plan is done, now I have to mark a column. So I say judge column. So what this program will do, it will go to each location and you have to say column is there or not. And I'm going to skip it, skip line, create, skip, create. So my columns are marked. Now I want to mark the beam. Beam marking is just automatic. You say beam auto beta, so it takes out the load and it works out the beam. So this is done. My beams are marked. So my complete floor plan is done. Okay. Now I want to see how much load I am getting from each column. So I say run. So it checks whether acting load and reacting loads are same or not. So it's done. So now for each column I am getting a load. So how much is the load? So here nothing is left to, okay, imagination. So it tells there is a load of 208 which is coming from 3 beams. And now suppose here if I go and I say you show me the okay, load analysis. So it tells me the load analysis. And what this program does, it works out the complete loading diagram. And in this one, okay, government, the more you give, less they check. So here it will take the complete thing. Once this is done, then I said, okay, now for the simplicity, because of time lacking, I said there are, suppose, there are 7 floors. Okay, I said save, and I say file save as. So I say save as, say T only, I have given T. Now I want to tell it that there are 7 floors are there. So I just go here, I say launch frame bin, and I said open a new file. Now it is asking me how many floors are there. I said there are 7 floors. And I say just now for the demo purpose, I have taken all the floors same. But I can have a roof floor, plain floor, typical anything. So I said okay. So now, and then just to save my time, I just copy everything down. Is done. Okay, and I'm giving some name of this complete structure as a frame. Now the biggest hurdle of any structure engineer is how to work out the column sizing. So here we have got, okay, automatic option. I said, okay, assign column sizing. Now it is asking me how much percentage of steel. I am starting with 0.8%, and because of wind and seismic, there is going to be some extra load. So for my experience, I know it will be about 40%. I said auto design. So complete this is done. It has worked out. Now if you see here, for this column, it has worked out all the sizes, 0.9, 0.85, 0.85, 0.6 is done. Now only thing, orientation I can change. And in ETAB or something, changing orientation is a task. So here what I do, I just go here, click here, it's done. Here it is done. Okay, now the problem with ETAB and all that, people take as a central line. Here what I can do, I can flush the column. I can flush like this. Now suppose here I am flushing like this, which is like if you have to do in ETAB, you are going to hate the day you are born, you know. So here is done, everything is done, and now you have to give only seismic and wind load. So just go here, you say assign wind parameter. So depending on which your city you are, okay, you say I am in Bombay, and height below the ground where the wind is not going to act. So I said till 3 meter wind is not going to act. So why unnecessary punish the structure? And this is actually a parapet height where the wind will act. Now then similarly I give seismic, that which city it is and which zone it is. So I say whether ductile, non-ductile, and it's done. Now I said create ETAB file. I said you generate. Now this program, the beauty is most of the engineers are using either state file or ETAB file. It creates both just with one click. So I said you create ETAB file. So ETAB file has been generated. Now I'm going to ETAB now. Okay, I told you that this software is used most of the time. So here it is created ETAB file. I said file, import E2K file. It's you want to save changes and all that. Now I am going to place where I have stored the file, that is IE seminar, planmin, and I have created this file, frame E2K, so it's done. Okay, it is importing the complete text file. So it's done. It is imported ETAB file. Now, Now for any structure engineer, creating ETAB file would have taken a lot of time. Now once it is done, then I just simply go here and I said analyze the structure. So I'm just, and ETAB is pretty fast at that, you know. So it is analyze the structure. I said done. Costing, yeah. I'm going to show you that. See, I had created for that big structure spreadsheet file. Now, if you see here, so these are all your quantity. It gives you the total steel required for the full building. How much full building for the shear wall? How much is the cubic meter? How much is the formwork? How much is 12 dia bar, 16 dia, 20 bar? And here we are giving in spreadsheet. So now suppose if you give your own rates, suppose say steel will be costing about right now 115 rupees, including the cost and the labor cost. So I just say you multiply this total steel by this figure. Okay. So now first let me finish because gentleman is waiting. So now this building has been done. Now ETAB also gives you how the building is going to move. So there is something called start animation. Now why we are doing this feature? Many of the structure engineer or builder, they want to save on C. So they say don't take earthquake. So now we scared them. यदि नहीं देंगे earthquake, तो आपका building गिर जाएगा. And then they see the movement. Okay. And then, as I explained, the draftsman will take over, make complete drawing, and these are the drawings which is made. I just give you brief idea about what draftsman does. In fact, what we are going to do now, see. Now see, this is a software drafting, and it does the drawing by a lighting speed. When I say lighting speed, I mean it. And I'm telling you, 1 month's drawing, including the quantity, we are finishing less than 4 hours for that big building I showed to you, right? So these are the element it takes. It does the footing design drawing, combined wall, column, beam, slab, staircase, and these are all the detailed drawings. Okay, what you are seeing here are all the detailed drawing. It also work out the quantity, bar dia wise, concrete wise, and the floor wise. Then summary of footing quantity, then column details. These are all your column details. These are the individual details. These are the drawing what I show you. That in about 3 minutes, it has created 12 A1 size drawing. Means it is designed for about 1200 shear wall. Now, right now, actually, what is happening? After E-tape gives you area of steel, your engineer convert into number of bars. Then he gives to draftman. Now, draftman does the drawing, which takes hell of time. Again he takes that and then checks. So all time is eliminated. Okay. So this is for the column. And these are the column quantity as you are asking. This is for the beam. Now beam, if you see, complete detailed drawings are there. All this one, right? And here the beauty is it takes ductile as well as non-ductile. So you just say you want means to do design as per ductile or non-ductile. Okay. And so now what we are doing, we are see most of the structures engineer. Their complaint is this: the fees they are getting are very, very low. So now what we have done, we have linked this software. So once you get a time, right now this gentleman is waiting for me to go. So actually what I'll be doing from 10th of June to 20th of June, if you share your email ID with me, then I'm going to give you fully functional demo version. So you can use for 10 days. Again I'm repeating, 10 June to 20th June, you'll be able to use this software free of charge. And if you do even 2 buildings, you'll be recovering the costs which you are going to pay to me. And with this, I'll take your leave. Thank you so much.
Sir, thank you for such an excellent presentation, and I seriously believe that this software is really going to help you. Any structural engineers, any civil engineers who are interested, who want to save on time, please meet him and try to understand the software. May I request Dr. Captain Bhandarkar sir to please, Bajaj sir, to please felicitate Mr. Prakash Bajaj. Now we have our final speaker, Mr. Akshay Hotkar, Deputy Director of Safety Council of India. He will run us through a safety presentation. May I request Mr. Atul Hotkar to please come forward.
माइक पण चालू करा ना. Okay, good evening all of you. Last but not the least, this is the last session of this, I think, seminar. And this is about the safety. So we normally in industry says that safety first. But now today is the safety is the last session. But you have to see that safety should be first during your construction. So I am Akshay Hodkar, Deputy Director, National Safety Council. Our headquarters is just beside 200 meter away from this hall. Okay. Construction industry overview. It is one of the largest employment sector because many workers are working in these construction sectors. One of the most hazardous sectors globally. Why it is hazardous? Because it's because of its dynamic nature. Because every time, every second, this construction site changes. If you see that non-compliance, if you see there is a pit over here, within 1 hour it may not be there. It may be there may a pillar will be there. So like that, this is a very dynamic nature, and multiple contractors working together. Many mechanical contractor, electrical contractor, or any excavation contractor working together. So it's a very dangerous situation. Simultaneously, different activities like mechanical material handling may be there. There may be excavation may be there. There will be different activities are conducting simultaneously. That's why there is a need for robust and proactive safety management system. So why construction safety matters? Because many civil engineers or many other organizations say things that the safety is the baby of the safety officer, but it is not. It is a baby. It is a responsibility of everyone. There are common accidents in construction sectors. These are the common accidents we have identified through our number of audits, number of ratings. Fall from height, this is the number one. Many fatalities are happening because of the fall from height, because of lack of safety measures, then hit by a vehicle, then collapse of lifting equipment like cranes and other things, and structure also, then collapse of scaffolds because of the poor scaffold structure, then electrocution, and there are many body injuries, like most of the cases are finger injuries, hand injuries, and leg and head. What are the common causes of accidents? There are many, but we have just identified what are the major ones, which is the poor safety standards. Lack of awareness. Now you can see that, suppose there is an electrical engineer in the construction site. The electrical engineer don't know what is the electrical laws related to construction site. It's a very pity to say that most of the construction engineers, electrical engineers don't know what is the legal requirement. They say that IA rules. Now IA rules is obsolete in 2010. Now CA regulation is there, Central Electricity Authority regulation, which came in 2010, and IA rules are obsolete. IA Act is there, but since then Central Electricity Authority regulation 2010 is established, and now 2023 it is again re-amended. So, but the engineers are not knowing about this electrical. This is a small, what you call example I can say. Even the safety officers don't know what are the legal requirements related to construction sites. Then production progress pressure over safety. That's everywhere. Unsafe lifting operations. Many riggers, many those who are involved in the lifting operation, they don't know what are the safety measures in the lifting operations. Because of that, a lot of accidents are happening. Equipment failure, poor planning and risk assessment. Risk assessment people don't know. They have to conduct the risk assessment before any activity. Then weak communication and coordination. They may be having excellent manuals, SOPs and all things in the paper. But if you see at the implementation part at the site, it is not like that. It is very much difference is there. Then inadequate leadership commitment. Lack of competency. As I said, engineers even don't know what are their duties related to safety. Poor maintenance and inspection of the equipments, and poor housekeeping. This is the most critical point, poor housekeeping. What are the impacts because of these accidents? Definitely high fatality rates and accident rates. Project delays, loss of productivity. Financial losses, because you know that because of the accident there are direct costs are there, but there are indirect cost is also there, which is much more than the direct cost. Then legal liabilities, because of the accident, there are many legal liabilities are incurred. Then damages to reputation. One accident now in the social media today's social media, it is highlighted frequently. Then there is a confidence loss in the stakeholders. Then poor morale to the employees and workers. That's why high attrition rates. Now we will talk about the rating system, why rating system is important for these construction sites. Because we have brought this in 2014, and we have again relaunched it in 2022, and we have started this national safety rating system, 5 golden star rating, and it is very much appreciated in construction sites. There are 9 major key elements of like OHS management system, physical hazards, mechanical, electrical, chemical hazards, fire and industrial hygiene and occupational health, accident reporting, investigation analysis, emergency preparedness and safety inspection. So this is what is the structure, and we have more than 100 sub-elements, and we do the assessment during the first visit, and we give detailed report, and we give 2 to 3 months of time to improve on that points. Those who are getting more than 95% marks, they will get 5 golden stars. If it is 85 to 95%, 4 golden stars. So we have rated many organizations. There are many benefits to this rating. Like it helps to element-wise analysis of the safety elements. It's a very good leading indicator, and it emphasizes more on the implementation part rather than just other rating system like that. Now you can also see that you can also compare your other construction sites, each construction sites with this rating system also. You can compare with the major elements also and the key elements also. Now about the sub-elements, as I discussed, there are 9 major elements, but there are 100 sub-elements are there. Now you can see in the OHS management system, you can see there are 21 sub-elements are there, like OHS policy, safety department commitment, budget, manual, SOPs, work permit system, contractor safety systems, like that 21 elements are there. In mechanical, there is a housekeeping, machine guarding, general area guarding, safety in storage, hazardous assessment, control, work at height, confined space, excavation work. So there are, you can say, 16 number of physical, mechanical hazards elements are there. Then comes the electrical hazard. All electrical installation, their inspections, their testings, their competent persons like electricians and all these things are seen in this element number 3. Then comes the chemical hazard about the lube oil and other chemicals that they are storing, how they are storing, how it is handled with the help of MSDS, spill control measures, gas cylinders and all these things. Then comes the fire and explosion. Definitely what are the firefighting arrangements like firefighting systems, fire detection system, what are the drills, firefighting trainings. Then comes the industrial hygiene and occupational, which is the most neglected part in the construction site. Like ventilation survey, illumination, noise is not being conducted. Then first aid facilities and medical examination, pre-employment and periodical medical examination is not being conducted. Then comes the accident incident reporting and investigation, which includes the near misses, first aid cases and other dangerous occurrences and fatalities. Then emergency preparedness. They have to prepare the emergency preparedness with respect to their sites. All the emergencies should be identified. What are the duties of persons, communication facility, resources available for the handling emergencies. Then 9th in the inspection of each and every equipment of the sites. So these are the 9 elements and 100 sub-elements where we do the detailed assessment and we give the scores. If it is more than 95% marks, we give the 5 golden stars. And this is the safety shield, which is the topmost recognition by National Safety Council. It is the organizations only apply those who are getting the 5 golden stars, and they can apply for that. In that, we see the leadership quality, we see the safety leadership, we see the digitalization used in the organization, and accordingly we give the scores, and accordingly we give the shield to the organizations. Now you can see these, there are many organizations, construction site, I'm talking about the construction sites, they got the safety shield with their best performance, and like AFCONs, and this is the construction site of international site. Then you can say this is a Delhi Meerut Metro train. Then Birla Tisya, there are different organizations those got the safety shield. So there are many benefits for the construction site with respect to safety for operational and strategic benefits, like lowering accidents rates and fatalities, reduce project delays, financial losses, less legal liabilities, then enhance reputation, higher employee morale, strengthen safety culture, improve productivity. And there are different systematic organization impacts like identify gaps, encourages to improve the advanced technologies, IoTs in OHS management system, enhances worker participation, and we gives more focus on the proactive approach. Our Indian culture is like reactive approach. For example, if there is accidents happen, then only we do the any corrections. But we have to have the proactive approach so that the accidents can be reduced. So these are some of the organizations who opted for rating, including construction sites. Now, how many construction sites are being rated by NSE? Like you can say that there are a number of sectors like chemical, steel, oil and gas, IT and commercial, thermal power plants, engineering plants and construction. Now this is the most industry is getting rated by NSE, like 23 in last 3-4 years among the 57. And percentage you can say around 40%. So 40% of organizations are rated by NSE for construction site. In construction site, there are different categories like commercial construction site, highways construction, industries, marine, then metro and rail. And metro rail is more where we will see the underground metro, or elevated metros, and all these things. Then residential, water projects. So major aspects in the construction sector that we have identified, like work at height, material handling, scaffolding, excavation, electrical, chemical, occupational health, and all these things. So these are some of the observations that we have derived from our audit. Like work at height, we have observed that these are the construction site. These are the points that we have observed that work permits is not followed. Vertigo test is not being corrected, SOP for yellow tagging is not there. So these are the, we give the recommendation to the organization and they improve on that one, and during the second visit we see that the compliance. Similar to for excavation safety, we give the observations, recommendations, electrical safety, material handling, PPE management. Now we can see how much PPE is being used in the organizations, damaged PPE is being used, and sometimes adequate PPE is not given to the workers. The workers are doing activities without the PPEs also. Traffic management challenges because a lot of traffic accidents are happening in industries. Industrial hygiene and occupational, which is the most neglected, I said. People are not medically examined for their different categories, like for high noise level, they should go to the odometry test. Those who are exposed to dust, they should go for the spirometry test. Those who are canting workers, they should go for the different CBC and other medical examinations. So like that, health awareness program is not being conducted in the construction site. Emergency is this is also one of the key element, I will say, or gray area in the organization, that people are not preparing the preparedness for the emergency, don't have the proper resources for management of emergency. Safety improvement through NSRS. Now you can see we have conducted first visit and second visit. I have just depicted one of the organizations that you can see in the first visit they got in OHS management system 86%, but because of our recommendations and enforcement, it goes to 96%. Now you can see for each and every element they got the tremendous improvement in that improvement in safety. Some cases it is from 60% to 95% is also happening. So NSR is very much helping to the organization how to improve their safety management system. As I said, different construction sites can be compared together so that which are the performing construction site and which is not performing construction can be compared at the corporate level, and you can take the proper actions regarding that one. This is the last slide. Conclusion and way forward. Our key principle says that the construction safety requires collective effort. It is not a baby of safety officer only. Strong leadership is essential. Preventive is always better than cure. As I said, you have to have a proactive culture, not the reactive culture. NSRS provide a roadmap for the excellence, and safety construction equals to safety of nation. So we should give the awards from the different organizations similar to National Safety Council, 5 Golden Stars and Safety Shield. So our commitment should be safe construction is not an option. It's a responsibility, it's a commitment. Benchmark, improve and excel with the NSRS. So thank you with this one. Thank you. Any questions regarding anything? Thank you. Thank you.
Thank you, Mr. Akshar Hotkar, sir, for running us through the safety system, rating system and its benefits. May I request VC Kamble, sir, to please felicitate Mr. Akshar Hotkar. Now we move towards the final event, that is the valedictory session. May I request the volunteers to please arrange the chairs so that we can invite the dignitaries on the dais. May I request everyone to please come forward. The ones who are sitting behind, you are requested to please come, move towards the chairs in the front. Request everyone, sir, please. All of you, ma'am. May I request all have come forward, please. It's a request to please come forward. I request Engineer SP Singh, sir, to please come on the dais. Dr. Captain Mr. Bhandarkar, to please come on the dais. Dr. Nilas Deshmukh, sir. Dr. Navnath Gadge, sir. Engineer VC Kamble, to please come on the stage. Mr. Manoj Darak, sir, please come on the stage. And Suresh Babu, sir. Sir, please come on the dais. Yes, Mr. Mahapara, please come on the dais. So, may I request SP Singh, sir, for the welcome address. Sucheta ma'am, please.
अच्छा ठीक है कोई नहीं. Good evening to all of you. आवाज़ नहीं आ रही है. सब थक गए. Very good evening to all of you. I welcome for the today's we have reached to the now valedictory sessions. Now time has come to now conclude the entire program. Since morning we are listening a lot of technical sessions, and it is really enlightened to everyone with the huge technical inputs. So for this valedictory session, I welcome to our Central Coordination Committee Chairman of the IEI, Institution of Engineers Headquarter, and who is coordinating for the entire country. And at the same time, he is also a chairman of the Marine Engineering Division Board. So, as a chief guest, I welcome you, Dr. Bhandarkar, sir. And Maharashtra State Chairman, III Navi Mumbai Institution of Engineers, Maharashtra Chairman, and past Chairman of Navi Mumbai Local Centre. I welcome to VC Kamble, sir. The Mechanical Engineering Division Board Chairman and immediate past Chairman of the Navi Mumbai Local Centre, and the Dean of the Father Angle FCRIT, Dr. Desmukh. I welcome you, sir. For the ex-Chief Engineer of the Bombay Municipal Corporations and the member of the Maharashtra State Centre elected members, and by default is the member of the Navi Mumbai Local Centre also. I welcome Ghadge sir for your presence. The member of Architecture Divisions, and who is a member of the MSc also, and his presence from the Solapur. He came here to enlighten and support us. I welcome to Om Darak sir for your presence here. Today's program, our secretary was due to emergency, he is not present here. So to support our activities, our Mapra sir has joined us, and he has given a lot of support to us. I welcome Mapra sir for today's sessions. I welcome to the today's sessions single-handed dealt by the person who is behind this entire activity, organizing secretary of the Navi Mumbai Local Centre for this event. Under the aegis of Architectural Engineering Division Board is being organized. So I welcome the Suresh Babu sir for this program. I welcome madam for your excellent program. So today madam has wonderfully conducted the program for the session of panel discussion. So I welcome madam for your wonderful supports, and since morning you are here and supporting us for the program. The program since beginning started with the welcome address, and then it is being followed up by the panel discussion with the specialist who has given very enlightenments about the high-rise building, how it is going to come, what all are the challenges we are going to face, and how we are going to address these challenges. The experts from the academia and industry has discussed in a lot. At the end, the program has come with the conclusion with the industry experts. They have come up with their solutions of the high-rise, like glass, what kind of to be used for the lift, how it is to be monitored and how it has to be handled. And then the other topics is being also covered throughout the session. So time is running fast. So I will not take much time, and I will stop here. And I hope you all has enjoyed the sessions, and thanks for coming today and making us to be a more inclusive for this kind of programs. And Institution of Engineers, already I have told you, we are since 1920 the Institution of Engineers is being formed, and more than 100 years is being completed by Institution of Engineers is driving a lot of membership schemes are there. We will also encourage all of you to become the member of the Institution of Engineers. Engineers bill is already placed to the Parliament. Any time it can become rules and guidelines. So might be the professional engineers will become mandatory for all of us. So I can request on behalf of Institution of Engineers, so you become a professional engineer of the Institution of Engineers. At present, there is no examination for the professional engineer, but the examination is for the international professional engineers. So later on, this may come up as an examination has to be qualified for that. So I may request to all of you to become a member of Institution of Engineers, and you become a professional engineer of the Institution of Engineers. I thanks to all of you for listening me. Thank you very much.
Thank you, sir. Now, may I request, sir, may I request SP? How do I do? Felicitation. May I request Dr. Captain Bhandarkar, sir, to please felicitate Engineer SP Singh, sir. May I request SP Singh, sir, to please felicitate Bhandarkar, sir, Dr. Captain Bhandarkar, sir. May I request Professor Suchita Matthew, ma'am, to please come on the dais and announce the students' competition.
Good evening all. Today we are launching an architectural student competition. This competition is not just for the architectural students, it is a collaborative work of architecture students and engineers and any other allied field. Today we will be launching the competition, and registration will start from the next month, like June, and the final will be in August. Basically, the theme of the competition is universal design. So I'll give this poster to the sir.
Thank you, Sucheta madam. And I am very delighted to announce this architectural hackathon competition, which is open for all the architectural students as well as professionals, and also in the field of engineering, all the branches of the engineering who are related to the high-rise building and architecture of the many construction activities. So all are appeal hereby to give huge response to this competition, and there will be prize distribution ceremony will be arranged in the National Convention of the Architectural Engineering Division Board, which will be held the Institution of Engineers Maharashtra State Center on 12th and 13th of September 2026. So I request all, just pass on this message to all our colleagues and friends to make it huge success. Thank you.
Thank you, sir. May I request our organizing secretary, Suresh Babu sir, to sum up the seminar.
It gives me an extreme delight. A whole day everybody was sitting here. Few people might have gone, but you people patiently stayed here, listened here, learned so many things. And I think we should continue these deliberations continuously. And today's we had two wonderful panel discussions. And one is about this human-centric tall buildings, and another thing was with challenges in the high-rise construction. Then we had wonderful speakers regarding Mr. Hussain, Mr. Ruda Pawar, Mr. Sishan Mubasir, Mr. Gurudas Parwani, Mr. Uday Kulkarni, Mr. Bajaj, Mr. Akshar Hodkar. And all this presentation has given us a wonderful knowledge and wonderful experience. In addition to this, in our souvenir, I think there are 9 wonderful articles has written, and one of the, I will just name the only author of these writers. One is, 1 minute. We have a wonderful article is written by Dr. Veena Shenai. I think everybody should go through this article. She is a founder and CEO of an organization called Inclusive, because whatever we design, whatever we build, whatever we construct, it should be accessible for everybody. It's not only for a very few people. It has to be accessible. Our public place has to be accessible to everybody. To that extent, Dr. Veena Shenai's article is a wonderful thing. She was an activist. Maybe in our next convention, we may, she's from Bangalore, she may come and give a presentation maybe in the next convention. Then another article is written about artificial intelligence and future of high-rise building. Is Mr. Deep Tej Kim Singh. He was a highly accomplished engineer. He did his MS of computer science from USA, then MBA from Mumbai, BE electrical engineering from IISc Bangalore. Then another writer, we got their article, is architect Deepthi Maithil. She is a professor in CTES College of Architecture, Chembur. She has written about the various challenges in the high-rise construction in the Indian context. Then we have Mr. Vijay Kumar. I think Vijay Kumar sahab kidhar hai? He left, okay. Mr. Vijay Kumar has written a wonderful article about design challenges, system strategies, and emerging technologies. He did it, and all this article got verified by the expert in the industry, and whomever that reviewed Mr. Vijay Kumar's article, he appreciated very well as per his thing. There was some minor correction here and there that we got incorporated. And all these writers we will be providing with a certificate. And suppose if the people are not here, we will be sending it by post. Then we have another article written by, regarding the structural challenges, written by Dr. N. Subramaniam. He is from IIT Chennai. He also very well accomplished professional. He is a researcher and he was associated with several projects. We are lucky to get an article from him about the latest trends and various challenges. Then I have written, it's not an article you can tell, it's a small story sort of a thing. Whatever I have taken, everybody has written everything serious and subject-wise. I thought we had to make a little lighter tone. For that purpose, I have written a small article in this thing that is actually comparing a huge tree with the high-rise building. Tree with a high-rise building. They are having a conversation. Tall building in conversation with the tree. And the tree is telling, see, I am supporting so many that natural thing, birds, animals, everybody depends upon me. Then tall building is telling, I am supporting hundreds of human beings. I am contributing, I am making them happy, I am making them safe, I am making them a thing. This, even though it is not very technical, but I think you may like it. Then, of course, there is another person who wrote the article is architect, town planner, and engineer, Dr. Purushottam P. Doijude. He is the director of Military Engineering College in Pune. He has written something wonderful article. Then, of course, Dr. Ram Charitra Mandal. Mandal sab hai? Okay. Ram Charitra Mandal has written a article about intelligent firefighting system design, concept for multi-story buildings. It has been appreciated, Ram Saab. These are the articles we got it, and we had speakers, we have panel discussion, article. With all this, I feel today's this event has turned out very good, and it is up to you people to decide whether you have got something from this or anything. I feel, these kind of a thing should keep on happening very regularly, so that, everybody, the main focus of this event was the collaboration between the professionals, architects, engineers, as policymaker. That collaboration is very much required for to make us a better city, better living standard. That's it. Thank you very much.
Thank you, sir, for beautifully summing up the seminar. May I request Dr. Captain Bhandarkar, sir, to please address the audience.
Good evening. Do you hear me there? Am I audible? Last yes. Am I audible to you? Great. First of all, I congratulate all of you for braving heat and June weather, and also to be present till the end of this session. Congratulations. My congratulations to Navi Mumbai Local Centre for organizing such a wonderful one-day seminar, trend setting, and credit goes to my friend Mr. Suresh Babu for doing from the day one. Well, throughout the day, I respected friends on that, Sri V.C. Kamble sir, our chairman at Maharashtra State Centre, council member and chairman of Vijay Institute, Sri S.P. Singh ji, chairman of Navi Mumbai Local Centre, Sri Nilesh Deshmukh ji, chairman of Mechanical Division, Dr. Deshmukh, chairman of Mechanical Division Institute of Engineers, Sri Dhatrak, our committee member from architecture from Maharashtra State, Sri Babu, Sri Mapara, most dynamic and hard-working, our member of Institute of Engineers, Navi Mumbai Local Centre, my friend Ghadge Saab, one of the excellent engineer and socially conscious. You might know when there was a tremendous fail down of administrative machinery, within a night he provided water and basic facility to the 10 lakh people overnight. And he was commended by the municipal commissioner of Navi Mumbai, municipal commissioner of Mumbai. Madam Sucheta Madam, Sri Rajesh Saab, distinguished friends, members of Navi Mumbai local, ladies and gentlemen. It's a proud privilege to be here to speak to you this evening. Well, if you're thinking after listening to various deflection, beam movement, cross sections, steels, foundation, you must be thinking that this guy is also going to speak something about it. No. I am going to speak only about you people. I am going to speak about your own welfare, your own safety. We have seen high-rise building challenges, but the one of most important challenge, how to make user-friendly, safe and sound for the resident. I don't think this important point has been discussed today to the desired level. So I am going to speak about that only. Well, high-rise building, and obviously very high people live there. आप और मेरे जैसी की तो बात नहीं है. And what I am going to speak, these high-rise people staying in those high-rise buildings, because of their position, they ignore very basic thing, that is safety. My friend Avinash mentioned something in the construction. But physical occupation, what should be there? The simple thing. Safety routes, safety precautions, assembly areas, what are the escape routes, what are the do's and don'ts. These people, they are not aware. My dear friend, safety does not start from the bottom. Safety starts from the top. Safety is the philosophy, top-driven, not the bottom-driven. So, if you want to make these buildings safe, we must inculcate habit of teaching these people, the resident, how to make their own life safe. The second important thing, which I see, even Babu sir presented during his synopsis. Today, world is changing very fast. The war has come to UAE, and from UAE to Mumbai, it will not take more than 5 minutes. So, we have to prepare our buildings for emergency response, evacuation, shelter station. Somehow, in Indian philosophy, this important aspect is missing. We are very happy. Nothing is going to happen to us. God willing, nothing should happen to us. But good people do not dig a well when they are thirsty. So their preparedness is much important. These were the two important points I wanted to tell you. You are tired, exhausted, saturated, and I will not take much of your time. I thank you once again, the respected dais, organizers, the staff, audio-video people, and students for their gracious presence. Thank you very much. Jai Hind, Jai Institution of Engineers.
We'll move towards distribution of certificates. I have few names here. May I request Mr. Omkar Davde? No. Miss Anushka Doifude, please come. Miss Neha Gorde. Miss Neha. Mr. Suresh Sriyan. Suresh Sriyan. Patil Rajashri Nitesh. Patil Rajashri Nitesh. Mr. Ramacharitra Mandal. Sir, please come. Mr. Ramacharitra Mandal. Miss Diksha Valmiki. Mrs. Diksha Valmiki. No. Nitish Doshi. Pinak Ramesh Chandra Kurdekar. Pinak Ramesh Chandra Kurdekar. Not there. Vijay Dhande. Mr. Prakash Bajaj. Sir. Mr. Praveen Wagh. Mr. Praveen Wagh. Padmanabhan Mitali Vitil. Please come forward. No? Sandeep Adagle. Mr. Sandeep, no. Nitin Sangule. Mahindra Babre. Mr. Dipanjan Datta. Mr. Akshar Adurkar. Akshar, Philomena Fernandez, Vishal Lakras. Vishal? Mr. Vijay Gupta. Mr. Joginder Pal. Mr. Joginder Pal. Kukreja. Mr. Abhijit Patil. Please come forward. Mr. Vikrant Ketkar. Sarika Bohir. Sarika Bohir. Nisarg Dhanwade. Tejas Thakkar. Prachi Patel. Prachi. Aishwarya Shirsagar. Leena Kumbhare. Soham. Gayatri Mahajan. Kishore Pandey. Kishore, Mr. Kishore Pandey. Mahendra Lingait. Abdul Majid. Ashok Gekwa. Anybody else is left out for the certificate? Come, sir. Anybody else is left out for the certificate? I once again announce anyone left for the certificate? Anyone else? Come. You are left? Come. Green media. Green media photography. Any representative from green media photography? You are from?
We registered yesterday.
Okay. Sir? Photographer? Rahul Kamri? Ranjit Singh Bish? Rahul Kamri, na? Rahul Kamri. Rahul Kamri. प्रकाश कोहली कोई है रिप्रेजेंटेटिव? Anyone left out for certificate? Would anybody like to give a feedback? Anyone from the audience would like to give feedback?
Good evening, everyone. It was a very wonderful experience over here. I was quitting. I was not, due to health issues, I was not able to come, but I decided to come in the morning only. So I really appreciate to have all the speakers and giving me such a wonderful experience over here. It was a very insightful learning over the many issues like safety and planning issues and the new softwares I have learned with the engineering point of view. So it was very wonderful to have such a, only the design part I should like missing, how should be designing in terms of very architecture point of view. So that was my feedback over this. Thank you so much.
Thank you, Abdul, for the wonderful feedback. Anybody else would like to give feedback? Please come, sir.
Thank you to all, and thank to especially to Mr. S.P. Singh, Kamli sir, and Desmukh Sahab, and other dignitary here. I want to say something about the safety point of view of the high-rise building, because there are so many building mandatory for the firefighting system. Firefighting system is the basic requirement for how to save the people, how to escape from the building during the fire activated. So nowadays AI and drone system is going to implemented by our government and some builders and who's constructing the buildings. So like drone system, nowadays more than 30-story building, because up to that height, people cannot able to immediately go to up to that height. So drone system is the best way. Nowadays Chinese already invented so many drones for, especially for fire suppression. Design system like a small bottle, hydrant bottle, they are lifted to the up to the height and they inject at the fire point, exactly same. Another new technology is coming like compressed air, foam and water mix. They, because of their they are saving the water and as well as they impact instantly at the fire point. And as well as there are so many room
For the advance information, sir, what is it?
Myself, K.D. Gupta. Good evening to one and all. There is no doubt presentation was very nice. And I would like to suggest one thing here in addition to feedback. Say, I would say here, as a audience, audience always expect some questions. Means panelists should attend the question of audience also. You should have this point into account in the future seminar. This is my point. And at the same time, what is the right thing is this, कि it has concern with discipline. You should have to have, you have written the program will start from 10 a.m. and will finish 6 p.m. You should have to have pay the attention. It should be means finished in all respect sharp at 6 p.m. Now it is leading. This is my point. Thank you.
So thank you for the feedback. We'll definitely consider your points in the near future. So we come towards the end of the seminar. So may I request Mr. Mahapara to deliver the vote of thanks.
Good evening, all of you. I am here for giving the vote of thanks after the full day session, which was very enlightening and knowledgeable, inspiring. The welcome, the inaugural session was also truly inspiring. And let me introduce myself, Yasin Mapara. I am heading electrical department at CIDCO. And at Institution of Engineers, I am a member from electrical side as a managing committee member. First of all, I would like to thank our CIDCO MD, Mr. Vijay Singhal, who has given full support for this program, seminar program, but unfortunately due to his busy session, some meetings and site visits, he could not attend this function of the inaugural function. Similarly, Dr. Kailash Shinde sir, IAS, he is Commissioner of NMMC. He was to be with us, but unfortunately because of his daily routine busy schedule, he could not be with us. We had a special guest today, Shri Anurag Sinha sir, Shri Bachchu Bhai from Akshar Developers, special guest Mr. Manish Bhateeja. He was on his way but could not reach here in time and because of his schedule. But he has supported with his message in the souvenir. We had Shri Navnath Gadge sir, ex-Chief Engineer BMC. He was a panelist also, and he has shared his beautiful experience and knowledge, and he has got a lot of experience in drafting the DC rules also, which I was just sharing with him while I was at the session break. So thank you sir for sparing your valuable times and sharing the knowledge, your inspirations to the audience, to the participants. Thank you from the Institution of Engineers and Architectural Board, Divisional Board. Then I would like to thank Dr. Nilesh Deshmukh sir. He is the council member, Mechanical Division at Institution of Engineers. Captain Dr. Bhandarkar sir, council member, as well as he is in Maritime Board also. Then VC Kamble sir, Chairman, Maharashtra State Center. Mr. Vasant Pandarkar, Secretary, Maharashtra State Center. Dr. Sandeep Deb, he is Chairman of Engineers Architectural Board of Divisional Board, Institution of Engineers. He had supported with his message in the souvenir. Thank you very much from Institution of Engineers. Architect Suresh Babu, he is the Organizing Secretary, Architectural Divisional Board, Institution of Engineers. He wonderfully moderated the panel session, first panel session. Thank you very much, sir. I thank Om Darak sir, committee member of Architectural Divisional Board, Institution of Engineers. I thank all panelists, well moderated by Suresh Babu sir and Suchita Matthew madam. I thank all the speakers who presented with their insights and shared the knowledge and their experience, particularly towards construction management, safeties and all that. Full day I was witnessing these sessions. I am an electrical engineer and mostly working on the power sector. I was just wondering how would I be able to, whether we should also think of some innovative ideas for bringing in power for fulfilling the demands of the buildings which are rising day by day to newer heights. The power demand will be the biggest challenge in the near future with megawatts of load coming in. So how would we bring that? Whether we can, I was just exploring whether we can shift from substation to package power plants in the building itself. Architects can think of that. Civil engineers while planning, planners can think of that. Secondly, I was just wondering whether like rainwater harvesting, whether we can think of power harvesting by storing the power in the batteries and infusing it whenever required into the buildings which are high rise, at least for the common loads in the buildings. Anyway, it was a good session for us to learn also. Though I was an electrical engineer from the construction industry, I learnt a lot of things. Thank you very much for the good presentations. Not to forget the contribution, thanks to the organizing committee led by Mr. S.P. Singh, Chairman of IEI, Navi Mumbai Local Centre, Shri Dr. Godbole sir, past Chairman, IEI, Navi Mumbai Local Centre, Pradeep Narvelkar sir, Honorable Secretary of Institution of Engineers, Navi Mumbai Local Centre. He is not with us because he has some pain in the leg and he is unable to walk. In the end, thanks to media, photographers for coverage, souvenir committee, volunteers, caterers, staff of IEI for the support service. Now, with the permission of Chair, I declare the session concluded. Thank you very much.
May I request everybody to hold, please rise for the national anthem.
सिंध गुजरात मरा जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे